this okay? I don't know if, is this better? Can you hear me if I don't speak into the microphone? That's a good point. I'm going to talk into the microphone for the audio quality. Oh, just checking. Is everyone here for the talk about Mina protocol and SnarkyJS workshop room 2? Because, okay. Just because I know that sometimes people get the wrong rooms. Also, so we've still got a couple of minutes. I don't have a time. I'm going to do a timer on my phone. That's stopwatch.
What would you like? I can tell you as well.
It's all right. I'll just keep a general eye on it. And also, I brought this prop with me. This is some of the swag we have. Actual recursive bags. So it's a bag inside another bag. If anyone wants one, I've got one here, and we've got more at the booth. So I said this joke to one guy earlier, and he gave me a kind of laugh out of pity. And then he said to me, the thing about recursive humor is it's very repetitive. So he actually made a much better joke than I did. I don't even know if he meant it or not, but I enjoyed it. I suppose I'll do a quick show of hands just now as well. How many people here know what a zero knowledge proof is? That's a good amount. Okay. Cool. And how many people have done some sort of zero knowledge programming before with either SnarkyJS or some other, tool or language? Okay, cool. That's good to see. So we're almost ready to get started. What should I do as well? Like, do I need to wait for a kind of signal? Is it like on the dot, half past, or do I wait for like a signal like we're live?
Yes, they'll give you a signal of yes, you can start. It's already live actually, so.
Okay to start?
Yep.
Okay. Thank you. Arigato. Just start my timer as well. Konnichiwa, everyone. My name is Angus, and I'm going to be talking today about Mina protocol and SnarkyJS. So, as a quick introductory slide here, as I said before, my name is Angus Maidment, and I am doing developer relations for the Mina Foundation. I live in Edinburgh in Scotland, and my Twitter is @blockchainbeard, so you can follow me on there. I also have a poll going for all participants of ETH Tokyo. It's about how you add people when you're kind of exchanging Telegram information. So I'd be really grateful if everyone votes in that poll. I've put a prediction for what I think the outcome will be as a SHA-256 hash, and I'll reveal it when the poll closes at the end of the day on Sunday. So there's a funny picture of me as well, blending into the background of the sign in my Mina hoodie. I've actually got the trackies on today, but no hoodie because it's too hot. So the structure of the talk today, I'll first of all introduce like the Mina protocol and give you a quick intro as to what like zero knowledge proofs are. I'll talk a bit about ZK apps, the kind of applications that you can build on top of Mina protocol. A bit of a deeper dive into SnarkyJS, which is the TypeScript library that you can use to build zero knowledge proof-based applications. And then I'm going to tell you about a program that we have got going at the moment called ZK Ignite, and also the next steps for how you can get started building stuff. So the first section, what is Mina? Mina is an L1 blockchain that's built from the ground up using zero knowledge proofs. And so to give a general introduction about what zero knowledge proofs are, it allows you to verify information in a private, trustless, and decentralized way. So that has a number of useful properties that allow you to do things like create ZK rollups and ZK EVMs, of which you might hear about from other people here at the conference. You can do private transactions and keep data more private or hidden in some way. It's good for doing private voting. It's got a lot of applications when it comes to identity as well, which is obviously an important aspect of like Web3. And also you can verify large amounts of computation efficiently. So a zero knowledge proof effectively says that you can prove that a program has run in a valid way and that the output is valid. You can prove that efficiently. So it's fast to verify the proof, and you can do that without seeing all of the inputs necessarily. You can do that just by using what we call the constraints. So that gives you options to give your users more privacy and security by keeping their information private, and also has implications for verifying things and scalability as well. So just to give you an idea, these are kind of like the function prototypes or kind of declarations for some cryptographic primitives that you might be familiar with. A hash function, you put a string into the hash function, which is H there, and you get out the hash, which is also a string. So you can tell that two pieces of data are the same if they have the same output from the hash function, right? There's public key signatures, so you have a sign function, so you take a private key, you can sign a message with the sign function, and that will give you an output of a signature, right? And then you can verify that signature using the corresponding public key, right? And so you put that signature, the message, and the public key into the verification function, and you get out, either this has been signed by that private key or it hasn't, right? So then you can tell if a private key has signed, like a message or a transaction. With a zero knowledge proof, right, the way to think about it is there's a compilation step. So you compile your program, and then that gives you, so you have some code, you compile it, and that gives you the verification key, which is a string. The verification key or index, that's a string. Then you have a proving function. So you have the program, you run the program with some inputs, right? You use the proving function to then generate the proof. The proof is a string as well, right? And so then, when you did the compilation step, you get the verification key, you use the proving function to create the proof, then you can verify. You take the proof, you take the public inputs, but not the private inputs, and you use the verification key that you created at compilation time. You run the verification function, and that gives you the Boolean. The proof is valid or it's not. So now what we're doing is you can verify computation, not just that something has been signed, but you can verify that a program is run correctly, and you can keep some of the inputs private or hidden. So you only need some of these inputs, the public inputs. So that kind of gives you an idea of how it's different to these other, the zero knowledge proofs are different to other cryptographic primitives. And I'm going to talk a little bit now about Mina protocol, which is, as I said earlier, a layer 1 blockchain that is built entirely using zero knowledge proofs. Now, as I said before, zero knowledge proofs you can verify efficiently. And so Mina is a succinct blockchain. It's been built using zero knowledge proofs so that it's very efficient to verify the state of the blockchain. So that means that you can verify the state and run like a light node on a variety of different hardware, including a mobile phone. So that's what that diagram on the left is saying. It works using recursive ZK snarks, so recursive like proofs to kind of link the states of the blockchain together and to move it on. And that's what this diagram in the middle is signifying. And so that's what keeps it lightweight as well, the fact that these proofs can be recursive. You can prove the last proof. You can kind of chain them together and the proof stays the same size. It's a constant size and it's fast to verify. And also, it's interoperable in the sense that because you have this lightweight proof that you can quickly verify, you can use Mina as a kind of ZK layer and then take the state of Mina and kind of verify it in other environments, including, for example, Ethereum, to have it function as a kind of ZK layer for other blockchains or environments. So this isn't just stuff that we're kind of postulating on. There's actually a grant being given jointly by the Mina Foundation and the Ethereum Foundation to this other foundation called the NIL Foundation, and they're building in EVM Mina state verification. So in the future, when this is ready to go, you'll be able to verify the Mina state in an EVM smart contract, which is pretty cool because then you can do whatever you want on Mina, verify it in EVM, and then do stuff on the EVM chain. I'll take questions at the end, but thank you, Jonathan. We also have the Open Mina web node. So basically, you can run this node in a web browser. So when I was referring earlier to that diagram where it says you can run a node on your phone, you can actually spin up a Mina network node in the web browser, right? So you could, in theory, submit transactions directly through the web browser without having to go to like a third-party RPC provider. So coming on to like what you can do with Mina at the hackathon, right, is you can build apps on top of Mina that use zero-knowledge proofs. We call them ZK apps. And so just to introduce the concept, to think about the concept of ZK apps, Ethereum uses on-chain computation. So you write your code in Solidity, and then you put the actual code onto the blockchain, and then all the nodes in the blockchain network, when you say you want to run a function in your smart contract, they all run the code that they have on the blockchain, and so it's verified by the fact that everyone does the computation, right, and gets the same result. All the nodes on the network. On Mina, the ZK apps use off-chain computation with on-chain verification, right? So you do a bunch of compute off-chain, and then you generate this proof that I was talking about earlier, and then that gets verified by the network. So this has a number of advantages. One, you can keep things, you can give your users more privacy by keeping inputs to the function private. There's no gas fees in Mina, so you don't pay for computation, you just pay for the block space. You do all the computation you want, you generate a proof, and then you put that proof in a transaction. All you pay is the transaction fee. There's composability using SnarkyJS, our TypeScript library, so you can kind of program your own ZK apps to fit your use case. And there's scalability through rolling things up with this recursion that I'm talking about. So the fact that you can use proofs to generate further proofs means that you can kind of roll things up and collapse them all down into single proofs that kind of verify everything that you've done. And also the interoperability thing through the blockchain being lightweight and quick to verify the state of. So to explain that in slightly more depth, just the process of it, just to kind of help you get a mental model of what's going on. When you do the compilation step that I was talking about, so you write some code that's going to be your ZK app, and then you compile the code, and that produces the verification key. And so then you'd send a transaction to the Mina network, that creates a ZK app account, so an account for your ZK app, and that verification key is stored in that ZK app account, right? So now you have a ZK app that is associated with this verification key. That's on the network, right? Now, on the left-hand side of this diagram, this is your ZK app. So you serve the ZK app to a user in a web browser, for example, right? They run the ZK app with some data inputs that they put in to the web browser. When they run the app, that's the program bit that we got out of the compilation thing that I was describing earlier. So they run the program and it generates the zero knowledge proof. So they generate the proof and they include that zero knowledge proof in a transaction. The transaction gets sent to the Mina network, and the Mina network uses the verification key that you sent when you deployed the ZK app, right? And then it uses the verification key with that verification function with your proof, and that then says whether this proof that you've generated is valid or invalid. If it's invalid, then the transaction is denied, doesn't go through. So that's kind of roughly how the verification happens. When you deploy, you put the verification key on the network, and then the network nodes basically check your proof against that key when you use the ZK app and create the proof. So ZK apps are composed of methods, right? And methods you can think of as like functions in other smart contracts. So there's this diagram on the right. Basically, you have inputs and outputs to these methods, right? You can have arguments that go into the method. You can have, there's a very small amount of like on-chain state that you can manipulate. And it says here some values from the state of the world. So that's, you know, another database that you have on your website or some other thing that you can kind of control or change. And then that's the input to the method. The method runs, and then as a result of the kind of logic in it, you can make updates to the state of the smart contract, or you can make updates to some other thing based on something that happens in your method. And so if you want to learn how to write methods, we need to go on to SnarkyJS. SnarkyJS is the TypeScript library that you can use to define, create, and verify zero-knowledge proofs. So it's giving you as a developer the flexibility to build applications that use zero-knowledge proofs without having to be a cryptographer or kind of a highly capable functional programmer who can understand DSLs in OCaml. I mean, if you are into that sort of thing, you should definitely still come and talk to us because, you know, it's all kind of under the hood, but SnarkyJS is basically giving you the TypeScript interface that a lot of developers are more used to. So here's some logos that you might recognize. So we have basically familiar tooling that you'll be used to. We've got good IntelliSense support in Visual Studio, which makes it the developer journey a bit easier. And you can write all your tests in JavaScript using Jest. So this is 5 steps to show you how easy it is to get started. The first one is to install the ZK app CLI tool, which is it's a CLI tool that kind of helps you with building, as in, you know, compiling, configuring, and deploying your ZK apps. Then it's one simple command, ZK project, creates you a new project directory, and it actually has a demo kind of smart contract in there already. The 4th step is to configure it with our kind of testnet information. There's also a step here where you need to go to the faucet. If the faucet's giving you any trouble, you can kind of come to the booth or message me or tweet at me, and I can give you some testnet Mina, because I've managed to secure a supply of it, especially for this weekend. And then all you do is ZK deploy Berkeley, and then, you know, that's it. You've deployed your ZK app. So to program in SnarkyJS, you also need to understand that we use field elements. So these are elements of a finite field, which we use because that's how the cryptography works in SnarkyJS. It can store quite a large number, up to almost 256 bits. So it's a built-in type in SnarkyJS, and it has built-in methods as well. So down here, you can see an example where you declare a constant called sum, and then you make it out of 2 new fields, one of which is doing the .add method to another new field, which is 3. So that sum will end up being 4, but it'll be a field element, right? Which is what you need to use if you want to do things in SnarkyJS. There's also some other built-in types, including some crypto stuff. So you got public and private keys and signatures. And also, like, there's a Merkle tree implementation that you can use for things. And these all have built-in methods on them as well. So if you want to find out more about that, it's all in the docs, or you can use it IntelliSense. If you use Visual Studio Code, that'll tell you, what the methods are. So this is kind of an example smart contract that, just to give you an idea of what it looks like, I thought I was going to have a kind of pointer that I could use. So I'll try and point, and I can actually refer to the lines. So in line 12, you've got this state, right, kind of variable called num. So you have a very small amount of on-chain kind of state storage. And then what this is doing is, this method down here on line 22 is saying we set the initial state to 1, which is a field, remember, because we're using field elements. And then the update method on line 26 is saying check, get the current state, check that is actually equal to the current state. So you're kind of putting it into the proof that this is the state that you got and it's equal to the variable that you have. And then it's saying add 2 to the current state. So then this is the kind of the demo smart contract that you get. So it'll just, every time you call update, it'll update the state variable by 2. So that's what SnarkyJS looks like. Also, this is the Mina colored theme that someone made for Visual Studio, like the syntax highlighting. So if you want to get hold of that, I think we can maybe link you up to it, but I'm not entirely sure. So next steps, recursion. We've been talking a lot about recursion, obviously making some bad jokes with the bag within a bag, but one of the really powerful aspects, one of the powerful features of SnarkyJS is that you can do infinite recursion, right? So you can use proofs as input to other proofs. So you can kind of roll proofs up into a single proof to verify that several things have happened with intermediary kind of proof stages. So this is a diagram here of kind of, oh, here's a snark, and then you put that into the next snark, and kind of the proof stays a constant size the whole time. So you can kind of infinitely roll up these proofs, right? And so an example that I'll take you through is in the case of a card game, if you're player 1, you take your turn according to the rules of the game, you produce a proof that you've done a valid move, you pass that proof to player 2. Player 2 can verify the proof, they can verify that player 1 has taken a valid turn, then they can make their turn. They can pass the proof to player 3. Player 3 can then verify that player 2 has taken a valid turn as well, right? And so in that way, you can kind of go through as many hands of the game, as many rounds as you want, and then you can do it all off chain. And then when you have the end proof, that's kind of the end state of the game, you can then put that onto the blockchain to show these 3 players have played 20 rounds of this game. Okay? And so this is something that's quite interesting. A lot of the time when people talk about roll-ups, they're talking about batching transactions together, right? But now with Mina and SnarkyJS, you can start to think about rolling proofs up together, right? And that opens up quite a lot of different kind of ideas and use cases. So that's something, recursion is something that is really quite exciting about SnarkyJS, and will open up new different ideas. So here is the prize pool for ETH Tokyo Hackathon. First prize is $8,000, second $6,000, third prize $4,000, and there's a $2,000 pool for kind of runners-up who don't get the top 3 but still submit a project that's built with SnarkyJS. There's also this program called ZK Ignite, which I mentioned earlier. It's a sort of cohort-based grants program. So you submit a proposal, there's some voting, and if you get funded, you get funding for your project. And also you kind of go through the process with a bunch of other projects. So it's a kind of cohort like that. And you get hands-on support and kind of training and kind of community type things going on. And so there's a new cohort starting on the 24th of May. You can scan this QR code to get more information. And one more QR code. This is like the hackathon starter kit. It's got a link to the documentation and also a couple of other things. So please come and talk to us after this workshop as well, or at the booth, which is in there. I'm not going to try and describe where it is. We've got a big Mina sign behind our table, though. And so that is the end of the presentation. Thank you very much for being here. We've got about 8 minutes left for questions. So I'll take this question down here first.
So there's a verification key per app, per ZK app?
Yes.
That means there's a trusted setup per app, like a
That's a good question.
color reference string?
There is not a trusted setup per app. And so it's because the proof system that we use, it's called Kimchi, and it uses something that's like bulletproofs that uses the inner product argument to avoid the need for trusted setups. Don't ask me to explain it more than that, because I don't know all the math, but it's kind of the inner product argument way of it's kind of like it's something that has, I don't want to call it a workaround either. I'm not sure the correct terminology, but basically there isn't a need for trusted setups because they use this inner product argument methodology. So
this verification key, what is it?
it's a string.
Okay. It's an input to each proof of the app?
So when we're talking about the network, the verification key, when you deploy your ZK app, the verification key gets stored on the network, and then the Mina network uses the verification key to verify the proofs. So that the verification key and the proof go into the verification function, and then out comes proof is valid, proof isn't, in a Boolean. Does
So the Mina protocol in fact use some Plonk light setup.
Plonk light? It's so it says that the docs say the proof system is Plonk-ish, right? And also there's the Mina book, which is a load of documentation about the proof system, which has a lot of math and a lot of cryptography, which I can point you to, which will have all the answers that you're looking for.
Thank you.
I'm sure.
So you mentioned when you deploy a ZK app, you store the verification key on chain, and there's also a very small amount of state that is on chain that is accessible to each of these ZK apps. Is that correct?
Yes.
How is the blockchain fixed size with that state? I'm assuming there's not an upper limit to the number of ZK apps that can be deployed on chain. So how can you store a verification key on a fixed size blockchain without increasing the size?
The only limit to the amount of ZK apps that we'll have on chain is the imagination of developers like all of you. Also, the blockchain isn't a fixed size in the sense that, so the state proof stays a fixed size, which you can verify the whole state of the blockchain from. But obviously, there's other things which kind of make up the blockchain, right? And that goes into how the Mina network works and the kind of different roles and entities that there are. There's different kinds of nodes, right, that have different storage requirements. But the fixed size thing, so you may have seen this before as well, it's a number of kilobytes. The fixed size thing is the size it takes to verify the state of one account, and that includes the kind of the overall state proof for the latest block in the Mina blockchain.
So the state proof is what's fixed size. It's not the state.
Yes.
Fixed size. Okay.
And so but to verify the state of a single account, it's a fixed size per account. So, and I think it would be, if you wanted to run a node with the whole state of every account, I think it would be n accounts times that number, but I'm not sure on that.
Gotcha.
I'm mainly dealing with the ZK app stuff, so, but I'm sure we can get someone to go in depth on the node stuff with you if you like.
Awesome. Sounds
at the
great.
booth.
I'll ask
Thank you. There's a question over here.
Thank you. It was a nice presentation. Could you tell more about the vision of ZK apps ecosystem, what types of products you want to have on it? Like DeFi, some games or whatever?
That is a very good question. So, we've just run the first cohort of that ZK Ignite program, and the kinds of ZK apps that were funded by a kind of council of electors who were kind of community members, the kind of things that are getting funded are L2 rollups that do kind of batch things together, transactions, or other kind of bits and pieces. But so we've seen a couple of roll-up solutions. We've seen data availability solutions. So at the moment, there's still quite a lot of infrastructure and tooling being built. There is one thing was really cool actually. It's a kind of verification app for people who get kind of different colored belts in martial arts, and you can kind of check who has given whom each belt and things like that. So that one was quite interesting. I think when it comes to things like DeFi, because the computation model is different to EVM, quite a lot of the things that we think about in DeFi, it's not really defined how to do it on Mina yet. So that presents to you an opportunity, I think, but also a challenge. So, you know, you kind of need to figure out a different way to do things on Mina, but then if you do figure it out, you'll be the first person to do it. So that's why it's both a challenge and an opportunity, I think. But we really are just getting started with ZK apps. So it's a good time to get in early.
Thank you.
One last quick question. One last one.
One last quick question.
Behind you maybe? Or, yep.
And you can ask me questions outside as well.
Okay.
I was just wondering where the proving actually gets done. Is it in the user's browser or is it somewhere else?
It's in the browser. So, yeah. So, I think we have like enough time to do this answer. So, you run a ZK app in the browser, and what that is doing is running the program and then producing the proof. And that's the proving, right? So, you run the program, you produce the proof in the browser, and then the verification happens in the network.
Okay, I'll ask later about timing though. Does that have substantial lag or is it pretty quick? Or
Yes, you're right. That is a question for come
yeah,
to the booth.
go into more depth later.
There's a lot of asterisks attached to that. So thank you very much, everyone, though. Bye-bye to everyone on the internet.
Hello? Okay. Oh,
Yes, system preference. Yeah. The display.
duh. Mirror. Oh, cool. Awesome. Okay. Hey everyone. So we are from Taiko. My name's Dave. I work on developer experience, and this is Brecht, our big brain. So yeah, welcome to our workshop. We're going to be talking about Taiko, which is Ethereum equivalent ZK rollup. And we'll be giving a little bit of like a workshop on building a dApp as well. Give an overview of the bounties that we have, and then also like give some insights onto like some cool things that you can build. Yep. So yeah, like I said, we'll just go over the bounties, talk a little bit about Taiko, ideas, and then code base walkthrough. Yeah, so these are the different bounties that we have. We have over $20,000 in bounty prizes that you can win. So we have best dApps. It's just like a smart contract dApp that you can develop. Infrastructure improvements, catch MEV, some interesting MEV stuff. ZK Zone, where you can work on some interesting ZK stuff. Protocol economics. This would be like a kind of a no-code bounty. And if you're interested in like economics and like kind of dynamic systems, I guess this would be a fun one. Ethereum public goods. We find this one particularly exciting. If you can do something that's just better for the whole space, that would be really great. And finally, just a fun bounty where you just can do whatever you want or think is interesting. All right, so what is Taiko? So basically, like I said, it's an Ethereum equivalent ZK rollup. And if you look at this graph here, you can see we have a few these two axes of like decentralized and centralized and Ethereum equivalent, and one that diverges from Ethereum equivalence a bit more. And we're at the extremes of both of these axes, where we're fully decentralized in terms of like proposing blocks and also proving blocks, and then also we're Ethereum equivalent in the sense that we don't make any changes to like the Ethereum stack, even more like peripheral things. We essentially don't really change anything to make it easier to generate proofs. Yeah, another word for this is a type 1 ZK EVM, if you're familiar with it. It's also L1 sequenced. If you're familiar with Justin Drake, he made like a post about something called a based rollup, which is using the L1 to do the sequencing. So when you propose blocks to create the Taiko chain, we just rely on Ethereum to do the sequencing. We're fully open source and MIT licensed. It's a community project. I think we have like 30 contributors on our mono repository on GitHub. And I think we have like over like 50,000 members on our Discord. So we really like try to keep everything open and let everybody just, you know, help contribute. We really like that. And yeah, as I said, fully permissionless, block proposing and proving. The only reason I said permissionless here instead of decentralized is because in regards to proving, maybe the decentralization doesn't matter as much as it being permissionless. But I won't go into too much length about that now. Okay, cool. So next, I'll just give like a run through of like how what the stages look like for the chain, right? Like as the chain is moving on, like what are the kind of steps that happen? So yeah, first you see here we have like these users of the rollup, and they submit transactions to the mempool, and everyone is able to run a node, right? You can just go to our GitHub repo and you can spin up a Docker image and run a node. So they're all running this node. It's a fork of Geth, which is the execution client. And basically, those nodes can run as a block proposer. It's just like an environment variable. You can enable it. And then after your proposer, you just look through the transactions in the mempool, and you can propose a block to the contract that we have deployed on L1. And yeah, basically, at the time a block is proposed, I think I kind of show this in the next slide, we can already like build the rollup state like right after we've posted that transaction data. And that's because like we have really well-defined validity rules that we derive from the Ethereum yellow paper. And we do those validity checks to be able to compute the next state for the rollup. So you don't have to wait for a proof or anything like that. At the moment a block is proposed, the chain can progress. So yeah, that's how we kind of derive the rollup state. Yeah, so in terms of proving blocks, you see here I have like these three colors, like blue is like proposed, and you can just like keep proposing blocks in sequence. And then in green, you can see is when you can prove a block, right? And really what that is it's just proving one state to another state. It's like proving that transition. But the reason why there's also this verified state is because it's assuming that the state transition that you're proving is like has a valid parent or a verified parent. So the first block, the Genesis block, is already implied to be valid because it's the first one. So it's only when all of the parent blocks have also been proven that we can consider a block as verified. Yeah, so you propose blocks, people go around, and also this block proving, it can be done in parallel. Yeah. Yeah, exactly. That's a good question. Like, so the next slide is like, boom, yellow. Yeah. So yeah, exactly. Okay, cool. That was a great question. Okay, yeah. So you can do all of this in parallel, and then like at the moment that they're all proven to Genesis, they're all verified. Okay. Now I'm gonna give it to Brecht, and he's gonna talk a little bit about like some things to think about as they relate to our bounties. So yeah.
Hey everyone. So yeah, I'm going to go over the bounties like pretty quickly. There's like a lot of details that we could go into, but yeah, there's quite a lot of bounties. Oh, all right. I'm a bit smaller, yes. So yeah, there's like a lot of like different bounties, and okay, to go into detail for all of them would be like quite difficult. So I'm going to be like pretty quickly describe some of the bounties, give some extra detail. But if you're interested in them, like yeah, please contact team members and they will give you some more information afterwards. So yeah, the first one is kind of like infrastructure improvements, where we kind of like the goal is to just like improve the usability of our chain. And so there's a couple of possible tasks you could work on. One is, for example, the NFT bridge. So we created an RC20 token bridge ourselves and an ETH bridge ourselves. So you could depend on that as like a sample of your NFT bridge. But yeah, our bridging is kind of like very flexible. So you can basically write your own bridging smart contract just by depending on like this L1 block hash that we bring available to L2. So our RC20 implementation is like one of them that you could use, but basically you can do whatever you want to make this bridge. The other one is also like bridging related. So currently we use a Merkle-Patricia tree check in our smart contracts. The positive thing about that is kind of like, yeah, we also like a type 1 equivalence. So this makes sure that we can actually reuse a lot of code that other bridges already used to do that. But the downside is that it's quite expensive because the Merkle-Patricia tree proof is like quite big. And also the verification cost in the smart contract is also like pretty significant. And so we can try to optimize that by, instead of like doing it in a smart contract, we just wrap the Merkle-Patricia tree check in a ZK circuit. And then we just have to verify this circuit plus a small proof. And so we kind of like balanced out the proof size, like the data size compared to like the computational cost. And on L2, the computational cost is kind of like less significant than the data cost. Yeah, and the other two ones is kind of like more UI related. So one of them is like, yeah, we have like an L2 block explorer. And currently it doesn't like add some of the ZK stuff to it. So for example, it doesn't show you if kind of like a block is proven, if it's verified. And so it would be great if users can actually, see that as well on the block explorer. Another one is like, yeah, we want as many people as possible to be able to run a proposer. It's kind of like necessary for like the decentralization of our block production. It's also necessary for some of the decentralization of our proving. So yeah, it's important that it's as easy as possible for everybody to run a node if they want to. The other one is kind of like the general like block like protocol proposing improvements. So here the goal is mainly to improve the efficiency of proposing blocks. And so yeah, one of the first tasks is kind of like improving the block proposing cost estimation. So the difference is like we really try to be as much as possible to like Ethereum, but the difference between L2 and L2 and L1 and an L2 is that proposing a block on L1 is completely free. It doesn't matter like how much data it costs, like how big a block is in terms of like data and things like that. And for an L2, this doesn't matter because we actually have to publish the data on the L1. And the costs for some of these resources that we use on Ethereum is also like time dependent. And so that's kind of like one of the more challenging things is kind of like, okay, proposers want to put blocks on our L2, but yeah, they still want to make a profit. So they have to have like a good strategy to do it. And so, for example, transaction data needs to be included on Ethereum for us. And so that takes data on the L1 blockchain. That costs gas, and so that needs to be taken into account if they want to be profitable. And the one other thing is also like what Dave mentioned is like we have like a based sequencer. So we kind of like depend on the L1 to do our sequencing. But yeah, if we have like no extra mechanism on top of that, that means that many proposers would submit blocks at the same time. And that would mean that many transactions would actually fail and like waste gas because like, yeah, many blocks would, like, yeah, many proposers would submit the same block and they would include the same transactions. And obviously that would be like very inefficient. So the way that we can improve that is to integrate flashbots, which allows us to proposers who say like, okay, include my block only when it's like successful, and then all other blocks will not be included. But that's great because yeah, they don't want to be included if another one, another proposer is faster than it. The other task is kind of like more exotic. So one of the things that Taiko protocol allows is kind of like these shared sequencers because our current protocol is kind of like already fault tolerant. So that means that a shared sequencer does not need to have like the full state available of all the L2s because it's okay for us for a sequencer to include a transaction that is actually invalid. So the protocol will skip over it. It's kind of like inefficient, so you want to avoid it, but we can fully support that out of the box. And the other one is also like similar to that. So for the base sequencer, we kind of like want to use flashbots to include like for the proposers to include in our L2 blockchain. The other one is like, yeah, if we have an L2, then there's also like math to be exploited on the L2. So being able to also have like this math boost availability on the L2 is like very useful for proposers to make money and like optimize for that. And the last one I'm going to talk about is like the protocol and economics. So yeah, the goal here is that the economics need to be like simple and robust. And so there's like two main fees that need to be paid. One is if a proposer submits a block, then he needs to buy block space. It's similar to like the Ethereum EIP 1559. The other one is that if you create a block, there's also like an extra zero knowledge proof generation costs associated with it. So that's the two main fees that need to be paid. For the EIP 1559 on the proposed side, it's very similar to like the Ethereum one, but there's like a couple of differences. For example, instead of like having a fixed block time, there's like no fixed block time on our L2. And also like it depends, like the L1 mechanism depends on like this variable block size, which we also don't want to support because it's less efficient. And like the final one is like the proof fee. So the proof fee is generally paid by the proposer, but it doesn't have to. It kind of like depends on the mechanism there. So yeah, there's some ideas on how the proof fee could be paid. So one of them is kind of like a race, where like the first that's submitted is actually gets a reward. For the auction based is kind of like depending on how much the prover wants to pay and how long the proof generation costs takes. Will know out. And the final one is also like an interesting one, where a proof of stake mechanism, where it kind of like depends on how much each prover gets, like Taiko stakes or something like that. And so then we can just use like statistics to give some of them depending on how much is staked, we can actually assign blocks to them. But yeah, that's it.
Okay, cool. Yeah, a lot of fun stuff there. Oh crap. All right, we're good. All right. So yeah, the next one is just going to be like me using open source tool that I made, which is called DApp Slaps. So basically the idea is that you can just in one click bootstrap your DApp. And I know there's a few variants of these, but I tried to make it fairly unique. In the technology that's used, like it uses Svelte, it's a monorepo configured with Foundry, and uses a lot of like kind of the latest tooling to give a really frictionless developer experience. And yeah, basically the idea is like just want to help so that you don't have to waste too much time like trying to like build your dApp and just get moving on like writing smart contracts or doing something like more fun. So yeah, you can scan this QR code if you want to check it out. But aside from that, I'm basically just going to like, you know, emulate what you would be if you're using this tool and like just set up a dApp with it. Yep. So let's see here. Okay, so this is the repo. This is the button. Yeah, so you just connect your GitHub. I'll just call this blah 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 blah. So yeah, it'll deploy it like on Vercel. And the only thing that you need is this like one environment variable, which is like a Web3 modal project ID. I'm gonna get one online. I think it's let's see here. I think Wallet Connect Cloud. Okay. All right, yeah, so you just create a new project here, and then it'll give you like an API key. I'll just copy this, and I'll add this, and then, okay, technically 2 clicks, I guess. All right, this might be like a little bit of awkward silence just because it needs to like build. I don't think it'll take too long though. Let's see if it cloned the repo at least on my profile. Oh, there we go. Okay, so, all right. As I'm waiting for this to build, I'll just like clone the repo and then like maybe we can see it locally. So you can just like follow these steps. They should be like fairly clear in the README. Yeah, so I'll just go through this. Maybe increase my font size. Okay. So just cloning this, and then what are the next steps? Yeah, it doesn't like clone the submodules, so you have to like do this one forge install. Let's see here. Oops. So cd into the directory. Do this forge install. If you need to install Foundry, there's like a link to it here. It's like fairly simple. I think it's just like a curl command. And then yeah, you can just run this setup script. And this will just install the node packages and also install the forge dependencies. Okay. So next step would be like generating this BIP39 mnemonic. And you don't have to do this, but I just kind of recommend this if you're hacking because you might want like multiple accounts, like multiple addresses. So, and you don't want to like use like your main one. So you can just create like a BIP39 mnemonic and use that. And basically you can use this as an input. If you're not familiar with Foundry, you can run like a local Ethereum node. And you can just send in the BIP39 mnemonic that you generate here, and it'll just bootstrap the network with these accounts and give them all like a bunch of ETH. So yeah, I'll just create that. And and then we'll set that in the environment file. There's a single environment file. We'll just put this here. Okay, source the environment file. And then I think that's it. Yeah. Okay, so I have 3 windows here. The reason for that is because we'll use one window to start the local Anvil chain. We'll do another one just to, like, I don't know, do random terminal stuff. And then the last one will just be like running the front end of the app. Is this done yet? Okay, cool. So this is done. So like I said, you literally just need to do that like 2 clicks, I guess. And then you can go and like, it'll be deployed. So you'll just have a fully functioning dApp that you can use. This doesn't use like any like weird, it's like very minimal. Like didn't put like any CSS or anything like that. It's like a single file. You can just rip it out and just use HTML. And it's just very minimal. So yeah, this is the dApp, but we'll get back to working on it locally. Okay, so I sourced the environment file. Now I'll just follow these 3 steps for these 3 windows. I'll start the local Anvil change with the BIP39 mnemonic. And you can see here that like it gives you all of these accounts that you can use along with their private keys. So you can just like take any of these private keys and you can just like import them into MetaMask so that you can like use it in your application. I guess I'll just do that as well. Okay, cool. I don't know why it says Sepoy ETH, but all right. So I started the local Anvil chain. That's good. Now we can interact with that. The second thing I'll do is like I'll run this script. It's a deployment script just to deploy like a kind of a dummy smart contract to that local Anvil chain. And also it uses like WAGMI to generate all of the types. So it's like fully type safe when you like interact with the contracts. Values required for fork URL RPC. Okay, so it's probably because I need to go in here. Yeah, I didn't source my environment file, so I think that was the issue. Okay, cool. Yeah, so this is just compiling the dummy smart contract. I'll go through the folder structure too, so you can like kind of see, but this just compiled and deployed the contract. I think we should have gotten a receipt. Yeah, this is like a transaction receipt here. Okay, cool. So now we'll just start like the front end of the application. I think it's PNPMF. All right, we can visit it on localhost. Yeah, this is the application. And let's see, does this work? Okay, cool. So it says, like, I'll just show what the contract looks like. So basically, like I said, it's a mono repo. Like, one of the folders has all of the Foundry configuration. The other folder is a Svelte front end. So in the contracts folder, like, we can look at the contract that I just deployed. It just said, like, hello world here. And the cool thing that, like, this has integrated is, like, if I update this, actually, yeah, if I update this and then I redeploy the contract, right, it'll just like update the contract address, which is used by the front end. And like now you can see here's like the new message, right? So like hopefully this can give you like really rapid development. You don't need to like change contract addresses or anything like that. It'll just like update all like reactively. Okay, so what else do I want to show here? Okay, yeah, so like I said, there's this source contract folder. There's obviously like a test folder if you want to like write unit tests while you're hacking, but that would be kind of weird. There's this this is the deployment script. You can see here, this is where it's deriving that mnemonic. Yeah, creates this smart contract. This broadcast folder has some like metadata from doing the deployment. Okay. Cool. Yeah. So this is just like you can just like interact with a contract here. Yeah. So it's pretty simple. It's just a dumb like dumb smart contract. I don't have enough support ETH. Okay. But yeah, I'll show one other thing really quick. I guess I only have 4 minutes here, and I want to be able to answer questions too. So like we have one page where we integrate the Taiko signal service. So Breck talked about that a little bit. It's really because our protocols like Ethereum equivalent, and we just use like Merkle Patricia tree for the state, like we can just send arbitrary messages using Merkle proofs. And the Signal service is a contract that we like expose where you can do that Merkle proof verification easily. So if you want to do that thing like build the NFT bridge or do something related to cross-chain messaging, then you can just use this as an example on how to interact with the Signal service. Okay, cool. So let's go back to the slides. Big thanks to everyone for like coming here and like listening. I think Taiko is going to be like a really interesting thing if you don't have too many ideas for the hackathon. We actually have like 20 people here in Tokyo, which is pretty crazy. And I know that we're all like really willing to just talk about anything. So if you don't like know what you want to build, like it's like there's a whole playground of things you can do. Like whether it's like economics, building a dApp, like doing something that's like not even really Web3 related and writing some scripts to run a node. Like I think we'd all be down. Just like stop by our booth. Like we'd love to talk to you about anything and help you build. So I guess now, like, does anyone have any questions? My RuneScape username? It's Dr. Supa Fresh. Yeah. Yeah. For blog proposers for Taiko. I'll just speak loudly if that's okay. Oh, I see. Okay.
Alright, so for block proposers for Taiko, is it just like first come, first serve for whatever hits the smart contract first on the L1?
Yeah, anyone can propose blocks at any time, but it's up to the L1 to decide like how those are included or when they're included. They decide to like pick up that proposed block transaction.
Up to like the L1 validator or like the whoever's proposing the L1 block.
Exactly,
right?
exactly.
Okay, yeah, makes sense.
Yeah.
Okay.
What do you view as the most important trade-offs to optimize for economically in the system?
Brack, do you want to go for that one? Maybe a better.
What are the most challenging things you've encountered so far?
Well, we kind of like want to narrow the problem down as much as possible. So what we do is not change anything to the Ethereum protocol itself, but instead we have to really optimize our circuits and our zero knowledge proof generation as much as possible. Because if it's too long, then transaction costs would go up, which would obviously be a bad thing. So the trade-off here is kind of like you trade in some of the efficiency for full compatibility, full equivalence. So it's easier for developers to develop on. But then we have to do our job to make it as efficient as possible.
Okay, great. Thanks.
I have questions on the block finality. Taiko block finality. Is that instant or we have to wait for confirmation?
It's instant, as in when the block is proposed and it's included in Ethereum block, it's finalized. So that means that the transaction order is fixed. Everybody knows what the pre-state and the post-state will be. It's just like that the information, like the post-state of that block, is simply not known yet by smart contracts. But anybody that's running a node and is just looking at the data as it comes in the roll-up smart contract can execute those transactions, know the post state, so they know exactly what the state is. And once it's in the smart contract, that means that it cannot be changed anymore. So once it's there, it's fully finalized, cannot be changed. Everybody knows the state except smart contracts. And smart contracts, that's why we need the zero knowledge proof. So the zero knowledge proof is there because we will also want to let smart contracts know what the latest post state is without having the smart contract itself execute all those transactions.
So I guess in practice, we don't have to wait for any confirmation then?
No, no, you don't have to.
So it is instant.
It's just for bridging, where like a smart contract needs to know what the L2 state is. Otherwise, everybody else knows directly when the block is proposed what the latest state is, so they don't have to wait.
Sorry, another question. Do you support or we have plans to support the privacy programming feature as in LEO or Mina?
Not on our layer 2. So if you want privacy, you'll have to run it as an L3 on our L2.
Awesome, sorry, that's time. Thank you so much.
Thank you. Yeah, thanks everyone.
Yes. All right. Awesome. Let's start. GM, I'm Flywheel. This is Miguel, and we're gonna talk about Worldcoin today. So, in case you haven't heard about us, Worldcoin, the shiny orb, and World ID, the identity protocol that we're building, we're gonna start with a little bit of the story. So, obviously, the world is changing very fast. We now have some amazing stuff coming in, AI, robotics, you name it, right? And it's becoming a little bit more of a problem of what is actually human and what are actually bots online, right? We're starting to see how intelligence is really no longer a discriminator online. And these sort of problems start to come up, right? Particularly in the exciting world of AI and with all of these advancements, it's getting really hard to know what's real out there. How do we make sure that value is fairly distributed and that we're prioritizing humans, right? So all of this comes to personhood. Why did personhood go away? But personhood. Oh, I'm sorry about that animation. All right, it's not a demo if something doesn't fail, right? But personhood. So this is what it's all about. World ID, what we're gonna talk about here today is about personhood and distinguishing real humans in the digital space. So Worldcoin, this is the goal of Worldcoin, build our largest network of real humans. And we're doing this by giving away the ownership. So we are launching the Worldcoin token, which will be distributed to every human on the planet just for being humans. And we're doing this because we can do personhood verification and ensure that a single person can only claim their share once. And of course, you run into the issue very quickly. How do you know who is a real and unique person, right? We've all seen this before. Civil attacks, quite easy to replicate yourself and make it look like you're 100 people and kind of like game the system. So this is the problem we started to solve and that we're now offering in an open protocol for anyone to be able to leverage. For Worldcoin, we want to do this in a fully private, inclusive, and robust way. So what does this mean is we want everyone to be able to have access to this. We want all data to be privacy preserving and kept in the ownership of users. And we want it to scale beyond 1 billion people. So we explored a lot of options. All of this turned out to be infeasible. I mean, email or phone. I think we can all create right now 1,000 of them very quickly. IDs is a lot of people, turns out, don't have IDs. You'll run into a lot of issues with the different types of IDs, forgeries, all of this. Web of Trust is actually a great solution once you have a trusted seed of humans, but then how do you bootstrap this? And then that leaves biometrics. So within the realm of biometrics, of course, there's several options, right? And these are just some of the options that we explored. But again, we ran into different issues. You know, fingerprints, it's easy to spoof. Remember, here we're trying to demonstrate that you're a unique person, not that you're you. So when you're, for instance, using your fingerprint to get into your office, you are just demonstrating that your fingerprint belongs to you. Whereas here, you know, I could very easily like make a little cut in my finger and now I'm a different person. Face doesn't have enough entropy to recognize beyond like billions of humans. DNA is very intrusive, very logistically complicated. Not a good option. So that leaves Iris, and that is how the orb operates through the entropy of the Iris. Then next problem is, all right, we know that we can use Iris to recognize 1 billion humans. How do we get the entropy of the Iris? And then again, we went through different options, and I mean, the TLDR here is phone sensors are very varied, and most of them don't have the resolution that's needed to extract the entropy to distinguish 1 billion people, and even then you get into issues with trusted hardware, right? Like, how do we make sure that you're not using a rooted phone that's feeding false data? And that's why we ended up building custom hardware, which is the orb. Yeah, this was a little bit of a long time to build, but here's the output. This little guy here. As you can see, we went through quite a few prototypes, all the way to this is where we are today, and a little bit of a sneak peek just for you guys of where we're gonna be tomorrow. This is already we are in test phases for this newer version. The whole idea is these orbs are produced to be in untrusted environments and very easy to operate, so that anyone can come in, do the verification, and walk away with their verified World ID. The orb does these 3 things. It makes sure you're a real, alive person. It makes sure that you're not doing anything fraudulent, like, for instance, that it's not like 2 people standing close together, prosthetics, you're not wearing glasses or things like that that would interfere with the entropy of your iris. It checks that you're unique, and it verifies your World ID. And this is your World ID. So World ID, you can think of it as a digital passport that lives in your phone, is completely self-custodial. World ID is based out of a key pair that is created on your phone, only lives there, and it's very the public key is what gets inserted on chain once your identity is verified. So beyond personhood, because your World ID already recognizes you as a unique human, more credentials can eventually be attached and issued within your World ID protocol, right? So today we are supporting the ORF verification, and we are launching a beta for phone verification. So kind of like the 2 ends of the proof of personhood spectrum. But the protocol is completely decentralized and agnostic. So we envision very soon other credentials will start to show up and issued by different parties. The World ID protocol. So these are the guiding principles for the World ID protocol. First and foremost is privacy first. It's not like privacy is an afterthought. We start with privacy, and we'll talk about a little bit more about privacy in a second. It's completely decentralized. The source of truth is on chain. It's a smart contract, and that's it. Permissionless, and all of it is open source. The hardware of the orb is already open source as well. You can already check it online, and we'll continue to open source the software and everything else, because that's what it's all about. So how can you use World ID? There's two ways to use World ID. You can use it as a signing mechanism, signing with Worldcoin, very easy. Or we have an advanced version that lets you do what we call anonymous actions. So signing, very simple. You know, you add a button in your app, in your website, signing with Worldcoin, and the user authenticates using their World ID. The benefits that you get is you get this credential on how likely the person authenticating is to be a human, because they've either verified at an org or they have phone verification, right? So as more signals get added, then this can become a continuous spectrum and let you verify at different levels. So if you're building, I just heard an idea about a dispatcher that prevents civil attacks and bots. You could do something like, well, if you're org verified, we'll give you 100 transactions an hour. But if you only have phone, we'll give you 5. If you have nothing, we'll give you 0, right? It's kind of like it can be thought more of a spectrum as more than binary. Anonymous actions is for a little bit more enhanced privacy use cases. For signing with Worldcoin, the person verifying will always give the app the same identifier to make sure that you're the same person authenticating. For anonymous actions, you can actually generate different identifiers for each of the actions that the user is executing. So a good example of this is voting, right? So say you're building a voting platform, you want each proposal to be voted only once per person, but you don't want to be able to link votes of the same person across proposals. So if I vote yes to proposal A and no to proposal B, we never want to be able to link those votes together. So what we can do is each of these proposals can be separate actions and therefore like privacy preserved across. All of this is accomplished because whenever you're using World ID, you do so with zero knowledge proofs. And the zero knowledge cryptography is what is one of the biggest privacy components of the entire protocol. You cannot use the World ID credentials without going through the zero knowledge proofs, which make it impossible to track users across applications or to kind of like break the privacy there. Yeah, you're good. I'll leave you with Miguel to show you a cool demo.
Yeah, so first of all, I'm just going to speed through this because this is basically the fallback if the internet breaks, but we're hoping that we'll be able to actually demo this in real time. But as Paulo was saying, the really cool thing about World ID is that it works on-chain, and it can also work off-chain if you need to. We have an API. It still goes on-chain either way, but the really cool thing about this is that if you're completely new to Web3, which I think some people here might be, or also developers that are not really that into crypto, you can still get the full privacy guarantees that Worldcoin provides without any of that. And it's also really, really easy to integrate. I'm going to show you that now. So first of all, I'm going to go really fast here because we're a little short on time, but everything that I'm saying here, if you go to docs.worldcoin.org, we have an excellent documentation that you can look into. It will explain how to do everything. I will like jump across it right now, but yeah, basically anything that you miss, it's going to be in there. And there'll be a link in the end of the presentation as well, and a QR code and everything. So the demo that we have the screenshots here is ChatGPT. I feel like at this point anyone knows it. This is not the official ChatGPT. It's a clone that we made just to showcase how easy it is to integrate logging with Worldcoin. So in this case, we are using Auth0, which is a platform that allows you to provide authentication services. And it's actually the same one that OpenAI chooses. And the really cool thing about all of this is that it took 0 lines of code to get this to integrate with Worldcoin, because signing with Worldcoin uses the same standard that signing with Google, signing with Twitter, signing with Apple uses, meaning that if you have any kind of package or library that supports any of those, like Passport, Supabase, Auth0, any kind of code that connects with those, you can probably really easily make it work with Worldcoin as well. And so the way that this works is the user will click continue with Worldcoin, then that loads up a QR code, And then on the user's phone, they would go to the Worldcoin app here, and then they just click the little QR at the top and scan the QR code. Now, you don't need to actually get scanned to download the app. You can use the phone signal that Paolo mentioned if you don't want to get scanned for any reason. And if you cannot get a hold of us also for like the staging environment, kind of like the testnet, you don't need any of this at all. You can just go right ahead. But I will get this pop-up on my phone. And as I click verify, it will generate the zero knowledge proof in my phone, send it over to the computer, and then I will be logged in. And in this demo, basically, we just like add a little human mode as a joke. Again, this is not the real ChatGPT. But again, sign in with Worldcoin, 0 lines of code to implement. You can obviously do it with code, but you don't need to, which is the really cool thing. For a slightly more complex example, basically, we have anonymous actions. And as Paolo mentioned, anonymous actions are more usually for on-chain use case or use cases where you don't really want to persist I know who this user is, and more want to let them do, well, anonymous actions. So for example, let's say that you're making something like, I don't know, Curious Cat or any of these platforms that allow you to like ask questions anonymously or vote on a proposal anonymously. You still want to prevent spam or prevent people voting twice, but you don't want to kind of like break the anonymous thing. You still want to be able to like have these people ask questions or vote without revealing who they are. And so if you did sign in with Worldcoin, sure, you would not know who this person is, but you would know, oh, this person, who I don't know who that is, just like did these 5 things. And as they do more and more things, you would maybe be able to start learning some things about them, like who their friends are or what kind of proposals interest them. Anonymous actions kind of let you reduce the anonymity pool to a single action. And what that means is, if I have a voting platform, I could make anonymous action for each proposal. And so within a single proposal, when someone is submitting a vote, I can, on-chain or off-chain, figure out, has this person voted here yet? Which is kind of what you want. But when you are doing something like a different proposal, if you're voting on a different proposal, someone votes, and you have no way of knowing these 2 votes from different proposals come to the same person. It's anonymous, so there's no way of knowing. As an example of how this might look like, we have this lens integration that we made a while ago that basically lets you mark your lens profile as belonging to a human. And ideally, this would help reduce spam or maybe be taken into account when they do machine learning. And if we go to the repository for that and the smart contract, and I'll try to keep this very simple so people that are not into Solidity don't get scared. Basically, the way that this works is we have a function here, verify, and this will get the profile ID. This is like the arbitrary argument that I am passing. Let me make this a little bigger. The arbitrary argument that I'm passing, and then these 3 arguments that Worldcoin just gives you. And again, this is on the documentation. We have a starter kit which with everything that you need to get started here. And so basically, the first thing that we're doing is we're calling the verify proof method on chain. And this will just say, is this proof that the user has given me valid? If it's not, the transaction reverts, nothing else happened, your code doesn't execute, so you don't need to worry about any of that. After it works, here's where you would usually say like, okay, has the user done this before? In this case, we don't want to make it so that you can only do this once. What we want to make sure is you have only verified your profile once. So if you have already verified a different profile, we will first unverify it and then verify the new one. In this case, we're using this ID, this anonymous ID that you get from the anonymous action, instead of just like by checking true or false, has they done it before, more to store the ID that they have verified and revert it. So it's more of like an advanced use case. On the website side, we have this library called ID Kit. And it's basically, it's a JavaScript library. We add React components, but if you're using Vue, Svelte, something else, you can still integrate with it. And basically just gives you a component here where you can pass an app ID that you get from our developer portal. We give you a QR for that in a second. And an action, which is just like a text description or whatever action, like voting in proposal, whatever, or claim NFT Tokyo. And then just an success callback. And basically what this will do is we'll open a model with the QR, like you saw me do before. And then when the user completes that, you will get your zero knowledge proof on this result part. And this is the part that you need to send to your backend or your smart contract for verification, whatever you are. And again, I'm going to reiterate this because on previous hackathons, some people usually just like
console.log the proof and get it done, you actually do need to verify this. Like, someone could just like inspect element, change some stuff, and actually get you a proof that is not valid. So you do need to verify it, ideally not on the front end. So again, if you have a smart contract, that's the place to do it. If you don't, have a server, an API somewhere, verify it there. Very important. Otherwise, it's not civil assistance. And yeah, basically, you, as I mentioned before, have all of the things that you might need here. If you have any questions, you can go find us in the booth. We also have a little like GTP4 powered chatbot here that you can use. So if I were like, how do I verify proofs on chain? It will give you the answer and the correct pages. So if you just like have a short question, you could do that. Or if you have ChatGPT, as everyone does these days, and you have the plugins beta, you could also use that to ask the same thing, and it will have access to your logs. So again, trust humans more. We have a Discord channel. We have on the ETHGlobal's Discord, and that will actually answer all of the questions there. We have a booth over there. It has like a nice purple shade, so you can find it really easily. You can also come find me really easily, I feel like. But yeah, you get the idea. Yep. Before my computer dies. And so, as I said before, this actually has a lot of really cool use cases. The main ones that we have highlighted are voting, are civil assistance in general, but for airdrops, which is our original idea, uncollateralized lending, NFTs in general, consumer incentives. I mean, this is a hackathon. You probably have a lot of ideas, but you can use it for almost anything. And yeah, as I said before, the docs that have everything also have a list of suggested use cases that you may want to use for inspiration. We have 20K in prizes. I'm not going to read through that. You guys know how to read, and it's also on the website and on the starting kickoff that we're going to do later. But basically, like, choose whatever suits you best, and yeah. As I mentioned before, we have a developer portal that you can use. That's the QR code. If you don't manage to get it here, come to the booth later. We'll give it to you. It's fine. But yeah, this unlocks the developer portal that you need to use in order to integrate it, to have like a nice image shown next to your demo in the app, all of the cool things. I'm going to wait for like another second for everyone to take a photo. Yeah. Otherwise, again, come to our booth. We'll give you the QR code. And yeah, all of the resources that I mentioned, and even more that I didn't mention, like starter kits, more ideas, all example projects that we have code for front-end and back-end, are at worldcoin.org/ETHTokyo23. So really easy to remember URL. Go there. You have an Ocean page with everything you would ever need. Again, any other questions that you may have, come to us on our booth, ask AI, whatever you want. And also, as like a little thing, if you want to see a demo of the anonymous actions, you can just like come by our booth and ask us about Worldy, and we'll just like give you the page to claim a nice NFT using anonymous actions. So you do need to like get on board with the orb in order to do this. Again, we're like demoing the thing. But if you want to get a nice NFT and try out the experience, feel free to do it. And yeah, that's about it. This is World ID. It solves the whole civil assistant issue that we've been worrying about for so long, that is becoming more important even now with AI. Also, a really nice anonymous identity solution for anything that you may want regarding privacy. And yeah, it's here, and feel free to use it now. I hope you have a good time hacking. Do we have time for questions? Yeah, so anyone have any questions?
Hey guys, it's not. Well, thanks so much. Just a quick question.
It's like
okay, now it works. What's the typical proof generation time and proof verification time, just out of interest?
So, proof verification time on the on chain is whatever it takes to mine a block, because that's what all transactions take on Ethereum. Well, this is Polygon, but well, all transactions take in Polygon, so I would say like few seconds. I don't know the average block time, but like I don't think it's more than 2 seconds. Proof generation, it's usually not the issue at all. The issue, especially in hackathons, is how much does it take to send it over, because Wi-Fi. But like Definitely less than 5 seconds, usually less than 2. It's pretty fast. It also depends slightly on the phone that you use. If you have like a very, very old Android phone specifically, they can take like maybe 5 seconds or so. But like we've seen that in general, like the blocker is more sending the data over more than generating the proof, because it's just like doing math on your phone.
So I only need to verify myself once, either with the orb or the mobile, and then it will be with you forever.
Yeah, basically the way that it works is you verify yourself once, then you have the key forever. If you have the phone verification and then you want to get the orb, you have to go to the orb. The phone is more of like what we call weak civil assistance, because, I mean, it's not that hard to have multiple phone numbers. I have two, but it's like harder to get like 100 or 1,000 or like multiple thousands. So this is why on apps we recommend to like add like tiers and kind of like give less access to the phone and more to the orb, because if your issue is to prevent spam, well, I mean, spammers can get phone numbers, but they can probably not get large quantities of them. So it's more of like this orb is not everywhere in the world yet. Like there's one in my city, there may not be one on yours. So it's more of like a temporary thing where it still gets you integrated with Worldcoin, makes it really easy to support both. And then ideally at some point, as we have more signals, you have like a more complete picture of like how human this person is, or like how human do we know this person is. Ideally, every person is human, but yeah, you get it. But yeah, basically you verify yourself once, either with the orb or the phone number. You have the proof and the key forever. If you want to kind of like update your verification, as in like you have phone and you want to like go to an orb, you can do that, but you don't need to like have an orb at home and scan yourself every day, basically.
Sorry, just last question. So everything of my personhood will be on chain as my World ID. What's the likelihood of, I mean, what's the worst case that someone hack it? How easy it is?
Right. Your personhood is not really on chain. What is happening with the orb or the phone number is your phone generates a private key, which is like separate from your wallet private key. And this key will be used to kind of like sign these proofs of personhood. So basically, on chain, there is just like kind of like the equivalent of the public key of this private key that you have. So really, there's like nothing on chain of like your personhood in a way. Same for the phone numbers. The phone numbers are hashed and like and you just like store the public key. The phone numbers are not given to the apps or put on chain. And so basically, the way that we've done it, the worst case that could really happen is if you somehow manage to like export your private key and give it to people. Which is not supported in the app yet, but at some point maybe we'll let you export your wallet private keys. Then at that point, that person could like generate proofs, and then by that point, we will have a way for you to go back to an orb, invalidate that key, and generate a new one. But basically, there's no risk of like you even doxing yourself, so it is pretty secure. Yep. Yeah. Thank you so much. Hope you have fun.
Hey guys, do you hear me? Sorry for the small delay. Today it's kind of, actually it's a long workshop, and I'm not sure I can handle everything in 30 minutes, but I will try. At least I will try to explain what is OneInch Fusion and why it's so, like what is the hype about OneInch Fusion and how it works under the hood. But let's make some small recap what is OneInch firstly. So basically OneInch it started as a hackathon project at Ethereum New York at 2019 by almost 1.5 men. Right now we have about 200 people. We have a lot of metrics. We have billions of volumes of dollars on multiple chains. We actually are one of the largest DEX aggregator on the market. We also have multiple other protocols like limit order protocol. We do have OneInch wallet. Actually, it's a list of protocols. And you can take a look on some of them here. One of the most popular one right now is limit order protocol and OneInch Fusion. Also, we do have OneInch Pro, that is product for institutionals, that provides KYC and AML policies. Let's make some intro about what is OneInch aggregation protocol firstly. Maybe you heard that OneInch is DEX aggregator, and actually it's true. We do have API for aggregation information on the DEXs. How basically that works? Let's imagine that you want to make a swap on the Uniswap. And in this case, let's imagine that you want to swap, for example, 100 Ethereum to some amount of DAI. And what will be the problem that you will have potentially? That if you will use Uniswap, they actually use specific pools, liquidity pools, to make the transaction, to make a swap. And of course, you will have some price slippage. What is the best idea how you can have the potentially the best lowest possible slippage in this case? You need to have multiple pools and try to split your 100 Ethereum amount to some small parts. It varies how small it is, but it must be that small that the price slippage in each pool where you will try to make a swap will be almost zero. And you need to do all of that inside one transaction. So basically, it's how OneInch works under the hood as a OneInch DEX aggregator product. We basically split, if you want to swap, for example, DAI to OneInch, we split amount of DAI to some small subparts and split these subparts to another subparts and try to route all this and emulate all of that logic through multiple liquidity pools for almost each DEX that have existed on Ethereum chain, for example, or on a Binance Smart chain, and trying to find the best option to get the max return and have the lowest gas for the user. That's pretty basic right now, and most of the guys are aware of it, but I just want to remind that how it works. And the main feature here is that it happens atomically. So, for example, if somewhere price goes wrong, we have some designed minimum amount that you will need to get. If you are not okay with that, the whole transaction will be reverted. So basically, you are protected from any edge case that can happen during this swap. But the main problem here is that if it's one atomic transaction, and in some cases, for example, if it's some shitcoin, and sometimes everyone needs to swap some shitcoins. In this case, if you have a lot of them, you can have a really big slippage. It doesn't matter how much DEXs you use, because liquidity for some shitcoins can exist, for example, only on SEX or on other chains. And if you are doing that atomically, that means that it's impossible to aggregate all of that liquidity in one atomic swap. You need to wait a bit to make it. In this case, the limit order protocol can help you. What is a limit order protocol? It's quite the same as basic limit orders on any SEX, but it's completely decentralized. So basically, you just sign a specific structure that you agree that our smart contract can withdraw the tokens from your account and fill it with, by using specific function and get some tokens instead. Basically make a swap, and anyone can use this function, and they just need to provide specific instruction from your side. It's a signature and data which contract they need, which token they need to withdraw. Basically, the limit order protocol allows to make a gasless transactions on your own side. I mean, you can make a gasless swap, for example, in this case. You can just need a proof, for example, for the DAI to the limit order contract and make a limit order, for example, to sell DAI for Ethereum. And anyone can actually fill this transaction on behalf of your user. And in this case, basically, not user is paying the gas, but market taker is paying the gas. It's a cool feature, but the problem here is that it's there is specific price condition here. It's fixed. So that basically means that if price goes wrong, you can wait for like 4 hours or for weeks to get a good price to make this order executed. If you will try to say in the tax terms, it's like market sell. There is no market sell here. It's only limit order and you need to wait. There is no any guarantee that it will be executed, even if the price will be the same as the market price, for example. What if you want to make something on the market price, but we want to make it like limit order? Is it possible in the DeFi? And actually, that's the question that we have. And right now, we can say that it's possible. It's actually, actually, it's the solution what we make with the Vonage Fusion. We want to make something like market price sell. At the same time, it must be like atomic. It must be limit order inspired. It must be gasless. It must be protected from MEV attacks all at once. And that's what is Fusion actually. It's a fusion of multiple protocols at Vonage. How it works? Basically, it's auction. You try to say that I am okay to sell a specific amount of DAI, and the rate is going down, and all of that is actually one limit order. And what it allows to anyone, for example, to the resolver, to the party who will try to fill your order, it allows to aggregate liquidity during that moment. So basically, you killed multiple issues at the same time. Firstly, you try to actually have a market sell feature, so you sell some tokens without any. You don't care. It will be already filled. There is a guarantee that it will be filled. There is high probability that it will be filled. At the same time, the price slippage will be a bit lower because you don't need to make it atomic. And for this case, we actually use price auctions, and this is like example of the curve for the price auction for the rates where the rate is going down during the time. It's basically it looks like Dutch auction actually. The main feature is that all of that logic is quite simple for the user, and there is almost no difference for the user when you try to use Vonage Fusion. It's quite the same as just make on-chain transaction, but it's off-chain transaction. It's basically signing a specific limit order on the side of the user, and that's it. But there are some additional features here. The first one, of course, is the gasless execution. What I mean is that as a limit orders is off-chain transaction, and also you basically just send some data to some database. That's it, and anyone can access to this signature to your data in this database and execute transaction on your side. The gasless execution doesn't mean that you don't pay gas fee at all. This gasless fee is just included in the rate of the Fusion order. And basically, it's still a bit more efficient than if you will try to pay on your own, because in the Fusion protocol, there is a specific gas optimizations. Basically, that means that when somebody tries to pay for your transaction, to fill the transaction, the relayer can execute multiple transactions at the same time. It will be one on-chain transaction, but multiple Fusion transactions in one transaction. It can save a lot of like gas, a lot of Ethereum gas, for example. And when when the volumes are large, it can be like 10 times more efficient, for example, than just paying on your own for that. So that's basically how any Fusion orders are working right now. Any off-chain orders are working. The orders going to the blockchain through relayers, through some market taker who is doing that. It's quite the same for the limit order and for the Fusion. Let's try to make it more complicated. Why we have a BUF protection by default here? Because there is no any blockchain communication on the side of the user. There is no any option how somebody can steal your data or re-execute it on your own. But it doesn't mean that there is no MIF protection for the resolvers. But the risks in this case are much lower than for the user, because when resolvers are trying to fill this order, they have risks that somebody can execute it a bit more efficient, and they can arbitrage the resolvers on their own. But the price difference here is not that critical, and it's more a case of the resolvers, how they can try to find the way how to protect from the myth. So the risks are lower for the users, a bit higher for the resolvers. And what about like liquidity feature? That basically, actually we can aggregate all the liquidity across multiple chains during some auction time. So for example, in case of any resolver, we don't have any design how you need to aggregate or how you need to fill the each user order. You just have a time for that, and it's not like forced. You can't be forced to execute any order as a resolver. So basically, it's open market, and each resolver just can aggregate liquidity from any point. In case of our shitcoins, for example, how it can work. We basically need just, for example, any shitcoin that's existing on the Ethereum and existing on the Polygon, and all liquidity is on the Polygon. You can see that there is a pretty good, interesting order on the Ethereum side, and there is no any liquidity to execute it right now. Any resolver can take some time and withdraw this liquidity, for example, from the Polygon chain to the Ethereum, and after that, it can be executed on the Ethereum side. It will be impossible to do the same logic, for example, on aggregation protocol, because it must be atomic and it must be instantly. And in this case, that's the instant profits for all the parties. It just makes the markets more efficient, because users can get more tokens in this case, and resolvers can get some profits from that case as well. There is some slippage for the user because of the price auction. The race goes down, but this spread is not that high because it's pretty open market, and it's very easy to to become a vanish resolver right now. So right now, let's take a look on some precise example about like price auction. I just want to say that we do have right now a more dynamic formula for each pair on each front end. So it depends on which token you are selling and which token you are buying. The price formula can differ. And for example, on Ethereum dire rate, if you try to to say that in the beginning when you're trying to make an order, a price auction, the price is going down not that fast. We are allowing like resolvers to like instantly fill this order. But if you see that during some like amount of time, like 1 minute, nobody feel it, that basically means that price is really very bad and nobody will feel, and we can make it a bit faster going down, making this period a bit more extreme. If it's still okay, that means that the market is changing rapidly, and we need to stop working like this and try to have the same stable formula. So basically, it's a lot of logic on the price formula under the way how you can execute the auction. It's another way how you can make the markets more efficient. It also depends on the pair and the liquidity of the pair. We also do take care of all of that. And it's another like opportunity how you can, for example, design something or propose your own price formula for specific pairs and make it more efficient. Just want to mention that. The whole picture actually looks like that. If you try to understand Vanish Fusion, is that market maker is basically users. They just need to sign an order, send it to the network of the Vanish Fusion. After that, Vanish network register this order as a Fusion order and share this Fusion order across resolvers. Right now, there are top 10 resolvers that can execute any order instantly. And if you want to participate or become a resolver, there is a documentation on our website how you can do this. Basically, the entry barrier for any resolver is quite low. It's about 100 Vanish tokens. And if you want to participate, it's just like less than $60. So basically, any resolver can fill limit actually it's limit order. So any resolver can fill this limit order through 1 inch smart contract. That is open source, and when it's filled, a limit order is executed and send funds to the maker. So basically to the user. So the logic is off-chain and on-chain at the same time. There are some questions. What is Vanish Fusion? Is it off-chain logic or is it on-chain logic? It's a hybrid. It's sometimes off-chain in some cases. In other cases, it's on-chain. But basically, it's quite the same as a limit order protocol, but more advanced, with more additional rules over limit order, if you want to try to understand it. Let's talk a bit how you can work with the Vanish Fusion. Basically, there are two options how you can integrate and work on the Vanish Fusion. The first one, actually, you can integrate Vonage Fusion to your app. Let's imagine you have a wallet or any app that needs to have a functionality to swap any token to any other token. In this case, it's pretty simple. We do have a Vonage Fusion SDK, and in this case, it's in JavaScript. We have a Rust version as well, and if you want, you can just use it. There is a pretty easy example here. I will show you 1 second how it works. So basically, in this case, you can use, for example, Node.js application to make a Fusion order. So we have Vonage Fusion SDK. It's open source and it's quite transparent. It's not that hard to install it. In this case, you just need a node. You need a private key. You need a maker address of of the user who will be creating a limit order. And what you need to do is basically have a Web3 node and our SDK. You just install our SDK, set up our SDK with our network, our URL of storage of limit order of Fusion orders, and Web3 provider. And basically, you just need to place an order where you specify a from token address, which token you are trying to swap, to token address that you are trying to to buy, and amount in from token address. So it's only four parameters for the function. It's quite simple, and in that case, I don't have enough Ethereum right now to execute this function, but basically, it's just one function. It's not a lot of issue to make it work. So it's the simplest way how we can work with Vonage Fusion order, and also it's gasless. So basically, I just want to add, when you will try to use, for example, to run SDK or Vonage Fusion SDK, it can be not working because you still need to make a proof of the from token amount to the Fusion contract. If you don't make an proof, you need to use permit function. In this case, it's more complicated if you want to combine permit and make a Fusion order. But it's possible, of course. We do support permits in the Fusion protocol. But in this example, you need to make a proof before you're trying to make a swap. So that's the one example how you can use Vonage Fusion orders. And the second one actually is to become a resolver. If you want to become a resolver in Vonage ecosystem, there is multiple steps what you need to do. Basically, the first one, you need to have some Vonage token staked. You need to apply as a resolver, and basically all of that is pretty decentralized. But if you want to be on the front end side, on the Vonage front end client, there are multiple additional steps that requires us to connect with you, to chat with you. So if you have if we have a website, we have a website form where we specify all the data, what you need to do to become a resolver. But basically, in the end, it will end up with a chat with our team that helps you to integrate and to become a resolver on our side. We are obligatory to make some compliance checks at the same time. But if you want to become completely decentralized, you can potentially do this. You can still do this. That's the main point about Vonage Fusion. That is, right now the network is much more decentralized, and we can't stop you to become a resolver because it's mostly on the smart contract side. I just want to explain a bit more how resolver works, how the logic under the resolver works. And for that, in this case, I need to open Vonage. Give me 1 second, please. So let's take a look at our delegate tab at Vonage front end. 1 second. So right now we have multiple resolvers, and what is it? Only top 10 resolvers in this list can be allowed to fill transactions. And what does it mean? All of them are competing for your transaction. Each Vonage Fusion order can be filled not atomically, but by parts. So basically, when you create a swap, multiple resolvers can fill the same transaction. It's their own competition between them, who will be the first one who will fill all of that. So they need to take care on their own how it's happening. Each Vonage Fusion resolver can basically share some profits with the user. In this case, for example, if you're owner of the Vonage tokens, you can delegate Vonage tokens to any resolver, and allow resolver to be on the top and fill the Vanish Fusion orders and get some profits. So the scheme looks like pretty the same as curve wars, as a curve staking, and but there is one small difference here, that basically Vanish Fusion resolver is not obligatory sharing the profits with the user. There is no direct scheme here. But if Vanish Fusion resolver will try to refuse to share the profits, you can just undelegate from this part and delegate to another resolver. So basically, on large volumes, it will work on the markets, like there will be market competition, and any resolver is obligatory to get some profits, to share profits with the user. If it will be lower than expected from the user side, you can just try to use another one. So as you can see, like right now we have about 8 working open sources, like open resolvers, and the market share right now is much more lower in terms of Vanish Labs resolvers. It's only about 2 months that we are working right now, and we have like pretty good results right now. I just want to add that we also support not only Ethereum chain right now, we do support Binance Smart Chain and a Polygon chain, and we have plans to support all networks that we have on the front-end side. So it's about 10 networks. So it will be ZK Sync as well. The option how you can participate as a user, for example, you just need to stake Vanish tokens. And I just want to mention, when you stake Vanish tokens, you lock your tokens for a specific amount of time. You can lock it, for example, for 2 years. In that case, you can't withdraw it for 2 years, but you have pretty good amount of delegated tokens. That means that you will have higher APR and higher profits from the resolver when you will stake it. So it's up to you how much amounts you want to stake and for how long you want to stake it. You can always unstake it before this locked period, but in this case, you will have some fee. And for example, if you lock your tokens for 2 years and you want to unstake it in the next transaction, you will lose like 99% of the total transaction in the fee. In this case, all the fees going to the Vanish DAO. So it's pretty transparent. If you have any questions, I'm pretty happy to answer that. I just want to show again our QR codes, how you can participate as a resolver and how you can create Fusion orders using Vanish Fusion Order SDK. We do have additional instructions how you can use Fusion on our documentation website. So basically, this link's going to our documentation website. So thank you.
Okay. So if a third-party partner wants to integrate Fusion to, let's say, a major centralized exchange, it has to be can they, they also have a DEX aggregator. Does it have to be a separate button, or can it be somehow fused between Fusion mode and they have their sort of the legacy swap mode, right? So how would that work out?
If it will be summoned on the DEX aggregator, it will be quite hard to aggregate it if they have only on-chain functionality. I mean, like in case of Vanish, for example, trying to integrate another Vanish. In this case, it's almost impossible because Vanish needs to integrate only DEXs. Fusion is not a DEX, and in the case of another DEX aggregator, it requires to make off-chain logic, and but they need only one atomic transaction, so it's not quite possible. Yes, they need like a different interface, and they need to explain the user that this transaction can be filled not atomically, but by some steps. There is like an auction here.
Just this one. How would you get historical trade data, like the trades from historical stuff?
Basically, each Fusion order is, in the end of all, is just on-chain transaction. So basically, if you would try to fill like if you want to get the data, you can just index you can use Dune Analytics for the data, or you can just go to the address scan and see all the Vanish resolver like orders that are executed on the Vanish Fusion contract. That's the one option that you can do. The second one, we do have right now like a database, like API, where there is a storage of all orders. You can fetch data there. But I do recommend that the best option is actually to index data from the node directly, or actually use Dune Analytics, for example, to fetch all Fusion orders. We do have a Dune Analytics dashboard for the Fusion, and we do have all the requests, all the it's quite transparent there how it's happening. So all the analysis about Fusion is actually quite open source and transparent. Yes. Like the main logic here is that it works like that. Right now, there is one more like edge case that potentially later the fusion order can be filled not fully. There can be some small amount that will be not filled. Right now it's handled like in the case that in most cases right now it's not very profitable to fill order by small steps. So usually resolvers they just fill it atomically in multiple, like in one step or two steps. Later with large amounts, it can be a small issue with some small amounts that are not executed. It's the same as, for example, one-inch limit orders have. It is the same issue. Like you can make a limit order for 100,000 Ethereum, and 0.0.1 Ethereum will be not executed in the end of all because it's just more expensive to spend on gas than execute this limit order.
Which actors in the overall transaction are paying for the transaction?
Basically, it's only a resolver that is paying for the transaction. And in the case of resolver, it's responsibility of the resolver to calculate how profitable the transaction will be for the resolver. So, and the price is going down. That basically means that, for example, let's imagine that currently Ethereum price is like $2,000. I want to make a fusion order to sell Ethereum for $2,000. Let's imagine I make this fusion order. But nobody wants to execute this transaction because the gas price is like $20, for example. Let's wait like 10 seconds. The price right now is not $2,000. It's like $1,099.99. In this case, for example, it's profitable, and somebody will come and fill this order. So the price is going rapidly down, and during the moment when the market price is a bit lower than the real price, somebody will catch and execute this order. It's quite the same, I think, as front running, or not front running, but as arbitrage bots are working on the market. They're just trying to compete to find the way how they can execute or optimize the market. There is a period of when there is an auction. Of course, it can be cancelled, but if you want to cancel it, it must be on-chain transaction. So that's the pain point here, that if you try to cancel it, there's no guarantee that it will be cancelled instantly. You need to wait that the on-chain transaction will be executed. So yeah, it's quite painful issue here, but of course it can be cancelled by the amount of time. But for example, in some cases, it's very edge cases, but sometimes it happens when the market is going not in your position, against you, all the fusion order can be not executed at all. In this case, yeah, it's just time constrained when this fusion order is executed. All of that is actually on off-chain data that you are signing for. So basically, you can see all the details how this fusion order will be executed. There is no any something that is not off-chain or not signed, or not in the permissionless way, basically. Right now, there are multiple, actually one incentive program to become a one-inch resolver. That basically means that we share some one-inch tokens, one-inch DAO sharing one-inch tokens to resolvers to help them to reduce their costs on building the infrastructure. There are some details on the one-inch website for that. So yeah, there are multiple incentives from one-inch team to help to build resolver on your own. And there are right now it's pretty high volumes on the one-inch fusion order. So I do highly recommend to take a look on it. I think we can end up this. Thank you so much.
Okay, cool. Hi, I am Emily. I am the developer advocate for Linea, a ZK rollup, and here I'm going to give a crash course on L2. So it's going to be high level, but also low level, and we'll see where we fall in terms of how much you understand what I'm saying. So I'm just going to go ahead and get started. There's a lot of information to cover. So first off, from the start, what are L2s? If you guys aren't familiar, basically, hopefully you've heard of these. Blockchain trilemma, why is Ethereum, like, it's a pick two situation, right? We have decentralization, we have scalability, and security. We need to choose three. What has happened is we've chosen as a community to focus on decentralization and security, but we don't have that scalability access, right? So what that means is we are going to be pricing out users because of high transaction costs and slow transaction finality. What does that mean, layer 2 to the rescue? So layer 2s are specifically the scaling solution for Ethereum. What that means is we are decreasing congestion by pulling off the execution layer from Ethereum and then creating that data and posting it back. When I say posting it back, I mean specifically this concept called data availability. So basically what data availability is the guarantee that all this data is going to be published to Ethereum. So this is what powers trustlessness, right? One common misconception is how many of you guys are like familiar with like Polygon proof of stake? Right. How many of you guys think Polygon is a layer 2? Okay, actually nobody. That's great. But like, I think it is a common misconception, right? They have their own consensus mechanisms. They have their own like security flaws. Basically, layer 2s right now, data availability is the key to defining the difference. So that's something to think about. Kind of an image of, like, we all love visuals, so just to kind of show you what that looks like, right, is Ethereum is the monolithic version is taking care of execution, settlement, consensus, data availability. It's doing a lot of stuff. Like I said, again, Linea or like rollups in general pull off the execution layer. Ethereum is handling settlement and consensus data availability. How does it do this? Here's another really fancy visual. Basically, there are various ways to do layer 2s. The kind of winning solution for it is rollups. So when a rollup, it's pretty self-explanatory. Definitely what it does is it rolls up all these transactions together and then takes that and then posts it to Ethereum once. But how does it do this, right? So when we talk specifically about rollups, there are two types, ZK rollups and optimistic rollups. How they differ is specifically on the proof verification part. So the proof verification is basically telling you, how do I know Ethereum, like, how am I proving that this data I'm posting is correct, right? So now we're going to dive into, oh, actually, I forgot about this slide. To further explain rollups, it's composed of a few parts. So we have the on-chain contract. So you're going to have a rollup contract on Ethereum that basically does the storage, monitors states, tracks deposits. The second piece is the off-chain VM. So this is where that execution is happening. And the third piece is, you guys might have heard of like operators, validators, aggregators, sequencers. That's a lot of words, but you can basically think of them as the people who aggregate transactions and then post that on. Specifically, when I talk about sequencer, that is a little bit of a separate concept. They are the ones who have like the authority of actually posting it. Next, okay, so now I'm actually going to talk about optimistic versus ZK. So optimistic rollups basically do prove verification by basically not proving verification. What does that mean? So they're optimistic because they assume that everything is valid. In order for it to be invalid, somebody has to send in a fraud proof. They say, hey, wait, that doesn't look exactly right. Let's run a fraud proof. If it proves that it's correct, then it'll post. If it proves that it's incorrect, then obviously that transaction is rolled back. What that means specifically is this concept of a challenge period, right? So in order for a fraud proof to be submitted or like that transaction data to be posted, we have to wait 7 days, basically, to give time for fraud proofs to be submitted. There are workarounds for this. So something you might have heard of with regards to optimistic rollup specifically is something like a liquidity pool. So that's basically kind of a separate entity that says like, we'll actually just verify it all for you. If you want to post it and withdraw your ETH immediately from the L1, we can do that for you. The only issue here is like, that doesn't really address the issue of like NFTs. The other piece is that is another like kind of hackable element if you care. So liquidity pools is something you might hear as a solution for the challenge period of an optimistic rollup. I don't think it's foolproof. And that's why we're going to go into ZK rollups. So ZK rollups essentially, basically, instead of waiting for a fraud proof to be submitted, we, I guess, proactively submit something called a validity proof. So what that looks like specifically, if you go back to this side right here, the proof verification is done via a zero knowledge proof. So if you guys have heard of zero knowledge proofs, it basically means proving the correctness of a statement without revealing the statement itself. I want to step in here again in case you guys are a little... I have heard a common misconception with ZK rollups specifically. I think when people think about ZK, they think about privacy a lot. And they're like, oh, all this is... but there's a difference between a privacy solution and a scaling solution. So ZK proofs we're using it specifically to like keep the data small, make that faster. That's for scaling. That's not the same thing as a ZK proof for like obscuring your information. So those are two separate things. We are a scaling solution, so I want to point that out. The other piece about ZK proofs that makes it really cool specifically is we think about there's a concept of like recursive ZK proofs. So essentially with a ZK proof, you can have like this information and you can actually put a ZK proof on top of that and make it smaller. And you can put a ZK proof on top of that and make it smaller, right? So there is like what you could call like infinite scaling that is enabled by a ZK rollup versus an optimistic rollup. So when we talk about ZK rollups, we want to dive in a little deeper. So there's this concept of the ZK EVM. And so basically like this is executing, I guess, Solidity or like EVM bytecode. And what does that mean specifically? So Vitalik put out this article of 4 different types of ZK EVMs. So when you think about the rollup space, you might have heard a lot of things like there's like Starknet. What else is there in the ZK space? ZK Sync. I'm part of Linea, Polygon ZK EVM, Scroll. There's a lot. How do they differ from each other is specifically in the ZK EVM portion. So at the highest level, we have type 4. So type 4 is language equivalent. It is not bytecode equivalent. So basically what that means is you will be writing in Solidity, but that will compile into something that is not readable by the EVM, like the Ethereum virtual machine. As we move further down, or I guess further down in number, further up this, I guess, table, we have type 2 EVM equivalency. So that's basically, it is language equivalent. So that means you can write like Solidity. Everything is going to be directly portable from Ethereum to the layer 2. And it is also bytecode equivalent. The difference here specifically is you can think of like being farther away from the EVM, I guess, is a bet that, EVM, I guess, inherently is not super compatible with ZK proofs. So performance is not as easily achievable. Whereas type 2s and then type 1s, which are fully Ethereum equivalent, then you're thinking about like the easier it is to interact with the Ethereum ecosystem, the easier it is to have the network effects of all the tooling that's already been created around it. Like everything that has already been built around Ethereum works out of the box, right? And so that's the really strong point. This is kind of like that's the win versus, I guess, type 4. And I'm not going to read everything on this slide, but it's just kind of the graphical representation of what I was talking about versus compatibility and performance. So type 4, the least amount of compatibility, or it's on the side type 4, but the highest amount of performance. As you go up, that's that. Cool. So now that we kind of have a basic overview of how all of that works, what it means, what is Linea specifically? So just fast facts, Linea is the product of 4 years of research and development at Consensus. It's actually pretty interesting. When we first started, we were thinking about, I guess, payment solutions, like anonymous payment solutions. The idea that ZK proofs could be applied to scale was actually just kind of no one thought it was possible. So we were doing a lot of ZK proof research. And then through that research, we realized actually scaling solutions are possible with ZK proofs. And so that's kind of how Linea first got started. The other piece, like I said, we are on the way to type 2 ZK EVM equivalency, or type 2 ZK EVM, which is EVM equivalent. Right now, we are at type 3. You can think of that as more of a transitionary stage. When we get to mainnet, the goal is to be type 2. The other piece is we are powered by an award-winning prover. So when you think about like the technical, I guess, underpinnings of how Linea works, we won an award. That's pretty cool. And the second piece is we actually are very new as compared to the other ZK rollups that exist in the space. So you might think like, I think Polygon recently came out with mainnet. We actually just opened public testnet March 28th. So that was like 3 weeks ago, I think, or less than 3 weeks. But in that little amount of time, we have like a lot of activity, right? So I pulled this morning. We have over 5.5 million transactions, 560,000 wallet addresses, a lot of deployed contracts. I just guess for comparison, I think Polygon might have like less than 1 million transactions right now. There are different reasons for that I can get into later. But there's been a lot of activity. There's a lot of real big excitement. Like, why exactly is that? Like, why are people so excited about Linea? So I'm going to dive into this portion of, like, how do you choose where to build? Well, the first piece is there's a lot, right? Like I mentioned, I was naming all these ZKs. There's actually more than this. There's more optimistic rollups. Things are developing. How do you choose? When I think about what I build and why I care about a rollup, there are a few factors that I'm considering, right? So I think the first thing that people consider is like, the reason I'm choosing a rollup is because I care about finality and gas fees, right? So speed of the rollup, how cheap it is, stuff like that. But the next piece is you want to think about liquidity, right? So how much like liquidity is on that protocol. So if you're focusing on building like a DeFi dApp, for example, you want to think about how much transaction volume you can get from there. EVM compatibilities/equivalence. So this is where I was talking specifically on like whether or not you want to leverage the network effects. So specifically with like Linea, for example, because we are EVM equivalent, nothing changed. In terms of when we were bringing on partner dApps, literally all they did was just redeploy, right? Because nothing had to be changed. If their code is written in Solidity, it should work on Linea. The other piece is users. So when we are thinking about building a dApp, you obviously want people to use it. So how many people are actually building or like, I guess, transacting on that L2? The other piece is security. So I think this is kind of where the reason people might focus on optimistic rollups versus ZK rollups. Optimistic rollups have been around for a while, so you could say they are battle tested to an extent. ZK rollups are a very new technology. Are there going to be bugs? Probably. We've only been around for like 3 weeks, public testnet wise. But you know, something to think about. I don't think I think this will be a solved problem, but we'll see. And then the second piece is future proof. So I think this is kind of where I'm talking about where do you think the future of this rollup will go? You know, like, is that EVM equivalency super important? Is it going to be able to be fast enough? The other piece is like, is that ecosystem just going to be supported in the long term? Other things to think about. So, I mean, like I said, I think for the most part, ZK rollups have won against optimistic rollups. I spelled optimistic incorrectly. Ignore that. But yeah, I think specifically when I talk about the differences between the ZK rollup on the Linea side, the Vortex is our prover technology. So when I talked about how, you know, you might think about a type 4 being able to be more performant more easily, our assertion is like, actually, our prover tech is going to be fast enough. You have a confused face. Maybe that's not true, but like that's our bet. No. But anyways, what does that mean exactly? So this is kind of like a high level of what it looks like. So I'm going to name these important parts. I can't explain them directly, but basically we have arithmetization. So you can think of arithmetization as taking like all of that. ZK proof can actually prove it. The inner proof system is kind of where that proving is happening. Arcane and Vortex is basically our tech to recursively make that proof smaller and smaller and smaller so that when we submit it to that verification contract on Ethereum, it is as small as possible, so it is faster and cheaper. That's my understanding of this. If anything is incorrect, I will let you guys know when I talk to our researchers. But yeah, so this is also just like another slide of what that looks like. It's very complicated, but basically what you can see is the language equivalency versus the bytecode equivalency and how that compares to Ethereum. So that's kind of all of them. But they're all really good and smart projects, so I'm not here to say one is better than the other. But specifically, why Linea? Like I said, so I think we have the basics of a roll-up, right? Cheaper, faster, secured by Ethereum. When we talk about ZK versus optimistics, we don't have that challenge period. Zero switching costs, so that's when I was talking about being able to take advantage of the existing Ethereum tooling system. Something I want to speak to specifically, and I think this is kind of in line with how future-proof you think it is. With Linea, the Linea is a default network on MetaMask. So right now, when you deploy to other networks right now, you have to go through the UX of like hitting add network manually, finding that RPC information, adding it all there. User UX is gonna be smoother. We live in the same company as MetaMask. So there is a partnership in that sense of we're very close to like the most popular wallet in Ethereum or in Web3. But yeah, that's that. The other piece I want to note as well, I think there is a lot of, people like to fight between L2s. I don't think that's necessarily true. So something we are exploring is something called the multi-prover theory. So like I said before, like things might have bugs, right? So at the end of the day, like we're sending it through a prover. If that prover has a bug in it, that's problematic, right? So what the multi-prover is saying is we're actually going to send it to multiple provers. So Scroll, Linea, Polygon, it's like people we're talking to. If there is a consensus on this is true, we've verified it in 3 different ways. So that is a lot more secure than, for example, if Linea was the only L2 that existed in the space. And so this is what I say when we're competitors, but actually it's very important that we collaborate. So yeah, that's kind of the future. The other piece to this too, I guess a sneak peek, right? We are in L2, but we are thinking about like building L3s in the future. That could be anything from more specific like app chains to, again, doing that recursive proof so that it is faster. The definition of an L3 is actually still in flux, which is pretty interesting. So keep an eye on the space. But yeah, so actually what does it look to build on Linea? I think the Wi-Fi is really bad, so I'm not going to do this live. But the first thing you need to do is actually get Linea ETH. Let's see if I can access, if it'll go. Oh, okay, I guess. So yeah, I mean, basically what happens is you're going to need to bridge ETH from Gurley testnet over to Linea. So this is kind of... I hope you guys know how to use a bridge, but you can just think of it like this and then send it over. If this is not working, like I think it will work, you can come to me. I have 2,000 Linea ETH, so I'm happy to share, but definitely like try out our bridge. But yeah, so the first thing you need to do is get Linea ETH to actually transact. The next piece is going to be choosing where you build your smart contracts. So I have an example specifically for Truffle, Foundry, and Hardhat, but because it is EVM equivalent, bytecode equivalent, you should be able to use like Remix, Brownie. I don't know what other people use, but like wherever you build, that's where you choose. So specifically with Truffle, so to actually, I can probably do this. Let's try this. So let's do a Truffle init project. Oh, I'm in a project already. Whoops. Okay, Truffle init project code project. And I don't have any demo code in here actually. So pretend I opened this and then, woo, I added all this stuff. Amazing. Wow. What does that look like to actually deploy? So to deploy, and I'm going to show you what this looks like actually. Oh, I already opened it. So here's Truffle dashboard running. If we go to Truffle dashboard, specifically, you can choose what chain to deploy on MetaMask. I chose Linea. If you want to deploy on Gurley, mainnet, etc., you can do this all here. I'm choosing to use dashboard because I don't want to expose my private key to you. And then you can just do a Truffle, migrate, network, dashboard. And if the internet works, something should show up. I don't know if it will, so I'm just going to show you. This is what it looks like. It actually sends in the transaction. You just hit approve, and then it happens. With Hardhat, actually, you can also use the dashboard. You would just fit it in here. and then deploy with npx like hard hat dash deploy RPC, like truffle dashboard. With Linea specifically, this is our RPC endpoint, rpc.girly.linea.build. We are permissionless public testnet right now, so that's how you would do it. Have any of you guys actually deployed a contract before? Oh, actually, most of you haven't. Damn, I'm just saying stuff as if you understand. Yeah, okay, I will briefly touch on contract deployment. So essentially, you have various tools. So like I said, Truffle, Foundry, Hard Hat, that help you manage the deployment process. So that's going to be writing it and then giving you the opportunity to deploy to a network, configure what those networks look like. So if you want to deploy to multiple networks, that would be part of like a configuration that you add to your Truffle, Hard Hat, or Foundry project. The other piece is like it offers testing functionality. Specifically, when you choose where to deploy, that's kind of where this network configuration comes into play. If you guys have deployed a contract before, what it looks like is this URL will just be replaced with like Girly testnet, will be replaced with mainnet, will be replaced with Polygon. What we're saying here is actually just needs to be rpc.girly.linea.build. It's exactly the same. You don't have to change any of Solidity code. So that's when I'm talking about stuff like StarkNet, for example. They are building in Cairo, so you will have to write a different language and then do it differently. But with Linea, you can do this. Yeah, okay, cool. And so Foundry is kind of how you use that too. I would be pro to explain all of that. So anyways, talking about how you can use Linea in your project. So basically, we have a very open-ended bounty. Basically, all you need to do is deploy on Linea. So whatever smart contract you're building, just go and change this address to linea.build. Show us the actual deployed contract on the Explorer, like the block Explorer. And then that's all the proof you need to actually, and then one more thing. Put Keep Calm and Love Tokyo on your GitHub repo so that we know you actually read these instructions. But otherwise, yeah, it's super simple. I highly recommend doing it. Basically, whatever you build should be able to be deployed on Linea. So yeah, this is kind of information. I have quick starts on actually the full deployment process of like how you set up a project and then actually write a contract and then deploy. I'm sorry, I just assumed everyone was already a smart contract developer. That was like very bad of me. But hopefully you guys will try it out. And that's all I have to say. Cool. Does anyone have any questions? No. Yes.
More of a general question about L2s, not specifically about Linea. On the roadmap for Ethereum, for essentially Vitalik's whole vision is to bring everything onto L2s and whatnot. And the first step was that all the rollups are being stored in the call data, and that the first step would be actually making the call data size larger. I'm still trying to wrap my head around as to how increasing the size of the call data translates into directly the throughput, like the TPS increasing, if you know about that.
That actually surprises me too, that he would want to expand the call data.
Yeah.
I don't know. I have 3 very good friends who are like the experts in the room. Do you guys have any idea? If not, I can write down your question and then take it back to my team.
Call data can be treated as a data availability space, and by expanding call data, this was like the simplest way without any more complex solutions on Ethereum to just give more space for storing the proofs. You were sending the proofs through the call data instead of storing them in the storage on Ethereum. You were just passing them on call data because it didn't really need to store them on storage. But instead, now for the 4844 on Ethereum, you're providing additional space for data storage that is outside of state, outside of call data. So instead of creating that in the transactions, you create a totally separate transaction type. So it's like continuation of the same thought process of like give more call data, but instead you're providing like the specialized blob transactions that only have call data and only care about that, but they're quite big and they have different rules of propagation. So this is coming potentially in, most likely in Cancun extension in a few months in Ethereum.
Thank you.
Thank you very much.
Cool. So that's my presentation. Let me know if you're building on Linea. I can help you with Solidity development. I can't help you with call data explanations, but that's where I am. Okay. Have a good hackathon.
Okay. Cool. Hi. Nice to meet all of you. I was the person. Sorry, this is kind of low. Yeah, I was the person sitting on the ground outside. So nice to see all of you here. My name is Sarah. Nice to meet all of you. If we have not met at the booth yet, I lead dev experience for Filecoin Virtual Machine as part of Protocol Labs, and I'm here to talk about the Filecoin Virtual Machine and how that can help you with programmatic storage for your smart contracts. So yeah, let's get into it. Cool. Just to get a show of hands before I start, how many of you are familiar with Filecoin? Okay, great. And those familiar with IPFS? And Filecoin Virtual Machine? Okay, I guess I'm here for a reason. Great. And then, okay, one last question, just because I always am interested to know this. How many of you think IPFS and are not clear on how IPFS and Filecoin are different? Anyone? Or everyone super clear? Cool. Okay. I will talk about it briefly because honestly, I joined Protocol Labs and then it took me like 2 months to realize that IPFS and Filecoin are not the same thing. So if anyone thinks that, I'm here to help to clarify, and so that will help you to build easier for your projects. Cool. So, oh yes, and if you're interested to watch us, me and my other colleague, talk and experiment and code live every single Thursday, you can follow us on Twitch. We try out different integrations, and sometimes we fail and sometimes we succeed. But yeah, if you want to watch a train wreck, you can always join that. Cool. All right, so I kind of get started to set the context. For the Filecoin master plan. So if you're thinking, what is Filecoin Virtual Machine, which it seems like some of you are new to, that's great because we initially started, we've been around for about 7 years. When we started, it was a decentralized network. And so that is Filecoin as its own. So the difference here between Filecoin and IPFS, Juan Benet, our CEO, actually founded IPFS at the beginning, and that was a peer-to-peer network, which means that when you store stuff, you're not paying anyone. That also means that your data, if your node is not being maintained, could disappear over time. So we then decided to come up with the Filecoin network, which is a blockchain, whereas IPFS is not a blockchain, where you can store data and incentivize storage providers to store your data for the amount of time that you want it to be stored for. So that is Filecoin, and that's how it's different from IPFS. These two are used together a lot. So we would usually store on Filecoin, and then we would pin it to IPFS so that you get quicker retrievals, as opposed to on the Filecoin network, you would need to then unseal your data cryptographically, and that takes some time and also takes a lot of power, which you can do eventually when you want to retrieve back your whole set of data. But we recommend that you use IPFS for faster retrievals. So these are how the two work together. And then we moved on to step 2, where we started onboarding a lot of the data outside of the committed capacity that we had on the Filecoin network. So I think today we are at, I think it's like 30 exabytes, which is just a lot of data. And so I think someone came by the booth and asked me how much data would it take to crash the Filecoin network. The answer was kind of not enough. It's honestly kind of hard to crash, but we have a lot of space right now, and so you can always upload data to that. And now we're at step 3, where we thought, we have a bunch of data. How do we then emulate what Web2 has as an AWS server, for example, where you have data and then you have computation on top of that, and you can run it as a full server. So that's what we really want to bring with the Filecoin virtual machine. And I'll talk a little bit about how we can enable you to write logic around the storage itself. It relates to what? VPS? Not VPS, yeah. I wouldn't say it's I wouldn't say it's private. Yeah, it's pretty open. Yeah. Cool. So so I clarified a little bit of that earlier on, and to be clear, FVM is a layer 1, and then layer 2 is where all of you are at for the hackathon. So I know it's 2 days. We've been in hackathons. We've seen and mentored a lot. I know it's a rush, so I want to get right into it and do a demo as well, so you can see what you want to use in the next few hours and tomorrow as well. So layer 2 is where a lot of the solutions and projects are going to be building on top of. What you'll be doing essentially with the FVM is you will be building your smart contracts. So we are fully, sorry, let me take a step back. What the FVM allows you to do fundamentally, without us talking about the Ethereum compatibility first, is that it allows you to write logic around the stored data on the network. So every single piece of data that's stored is part of a storage deal. And every storage deal has like some metadata with it. So it'll tell you like what size of file is in there, how long is it being stored for, etc., etc. What the FVM does is it computes over that metadata. So it allows you to move around your data without actually having to open up the whole piece, which takes more time and costs you more money. So it should be pretty cheap for you to be able to move your data around. So that's fundamentally what it does, right? So now, why I say we are here today is, so this over here is the FVM on top of a Filecoin node. So every single node in the Filecoin network can run an instance of the FVM. You can also run multiple instances of it on a node. And then on top of that, we have 3 classes of actors that run on top of the FVM. We have the first class, which is built-in actors. And these are, think of actors like smart contracts. These are built into the Filecoin network. You aren't able to touch them. These are system actors that we have built for you to function with the protocol. And then you have the second class, which is user-defined WASM actors, which are, we consider FVM native. So we run WASM time under the hood. This will allow you to use different frameworks that you're more familiar with, like Go, WebAssembly, so on, assembly script. So we have these SDKs as well. But then for the Ethereum community, we were like, that's a really, really big community, and we should be able to provide tooling for them as well. So we've created foreign runtimes. And we also have built it in a way that we are VM agnostic. So today we are EVM compatible. In the future, we also have the infrastructure to allow us to be compatible with other VMs. So Solana is something that we're looking at next. We need to tighten up our Polygon story a little bit more. I will answer any Polygon questions later on. But yes, as of now, we are fully Ethereum compatible. So any tooling that you're familiar with, like Hardhat, Foundry, Truffle, you can use with the FEVM. And so you wouldn't actually see the FVM. A lot of it is on the back end. All you'll see is your Solidity code and your contracts, and you just need to understand how our contracts work and how you import that into your stack. Yeah, so pretty easy to use. The clear definition here is that you will eventually deploy to the Filecoin network and not to the Ethereum network or to the Polygon network, for example, which I know for some of you is a choice for you to make, but I just want to make it very clear that you'll be deploying to the Filecoin network if you choose to use the FEVM. Yeah, that could change in the future, and we're hoping to bring some more interoperability, but as of now, it will be to the Filecoin network. Cool, so we'll get right into it on how to use FVM in your project. There are two main ways that I think you can use as part of the hackathon today. So the first way would be the client contract. The client contract is a Solidity contract that we've written. It basically allows you to store data programmatically onto the Filecoin network using Solidity. So I'll run through a demo and show you how you can use it. These are some of the tools that we're using: Hardhat, MetaMask, the Hyperspace testnet, which is a testnet that we own. It's a stable testnet, and it emulates our mainnet. So if you've used it there and it works, it should work fine on the mainnet as well. We have a specially created filecoin.sol library by our partner Zondex. And so what it allows you to do is that you can use Solidity methods to then interact with the Filecoin protocol. Setup that you'll need if you want to build it out later on, npm Node.js, Hardhat, and then I think the new component here is connecting your wallet to the Hyperspace testnet and getting some test fill to use as part of your project. So yeah, we'll go through the demo. What we'll do for the demo is, one, I'll show you how to connect your wallet. It's super easy. We'll get some funds from the faucet, and then we'll deploy the contract. We will then prepare the data, and just for you, those of you who are new to the Filecoin network, any piece of data that gets stored there has to be converted to a new format called a car file. It is basically like a DAG, and it will be a new kind of format that you need to use in order to store that piece of data. I can explain more specifics in it as we get into the demo, but if you're just using it as part of the hackathon, you don't have to get too deep into it, but I'll take you through step by step. And then we will emit the storage deal proposal, and then we'll check the transaction on the Block Explorer to ensure that that has been deployed. Cool, so we will get into the demo itself. So I'm just going to use a bare bones terminal here. I hope that's okay with everyone. There is a really easy tutorial that will bring you through this. Hold on. So if you have come by the booth, we have a QR code there. It brings you to the hackathon cheat sheet. And in the cheat sheet itself, it will bring you to our Hardhat starter kit. That is the main flagship starter kit that will get all of you started on what you need to build. I will show you. And once you get to the Hardhat starter kit, it's actually pretty easy to get it going. We have most of the steps in there. It's super easy to follow. So yeah, I'm just going to show this to you first and then walk you through it, and we'll try it out on the terminal. So this is the Hardhat kit. It takes you step by step really quickly to show you how to clone it, get what you need to then save your private key. I will be using a test private key. If you steal my private key, you'll just get a bunch of test fill, which is fine. But don't do it because I need it for demos. And then we'll test it out to show you how you can get your address. And I'm going to talk a little bit about what an address means when you look at it as an OX address versus a Filecoin address, and how we've actually had an address manager that helps to convert that. And then we'll deploy the basic deal client contract itself. And I can talk a little bit more about these examples, but the rest of the contracts in the repo are actually more example contracts more than anything else, just to prove that you can mint an ERC20 token and so on. And then we'll interact with the contract to then deploy a dummy JPEG. And then we'll see the proposal get emitted and check whether that transaction has gone through. Okay, and one step before we do we get right into the terminal itself, I'm going to show you how you can connect your wallet. So where is my browser? Cool. All right, so easy, hit the chainlist.org, search include, make sure to search include testnets, key in Hyperspace. I've already connected my wallet, but then here you go. So then it should pop up over here, and if you click add to MetaMask, it will get it connected to your MetaMask. So once you have it connected, I'm gonna let y'all take a photo here. Once you have it connected, you can head over to the faucet. And all these resources, again, are in the Hackathon cheat sheet that I will share the QR code for later on. And you can always hit by the booth and get the QR code if you haven't had time to get it. Cool. So all you have to do is, see, as I mentioned, all you'll ever see is your Ethereum tooling. You'll just copy your MetaMask address. It's an OX address, not a Filecoin address. And you will answer a very complex set of questions over here. You know, honestly, these tests are getting harder and harder. Okay, honestly, it's okay. They just want to make demos harder for all of us. Wait, is that a... Wait, what is that? Is that a camera? No, okay. Sorry. Can deploy contracts, cannot answer. Oh, there's a... They're all black and white. Okay. That's it, right? Okay, cool, teamwork. We got it. And then you send. And typically it takes about 30 seconds to a minute. The reason for that is that our hyperspace testnet, which simulates our mainnet, runs in these things called epochs. And so every single epoch is about 30 seconds for a new block to come in. So that's usually the wait time that you will take. I would say give or take another 30 seconds. So we usually wait up to a minute. But of course, I already have some test fill in there, but just to manage expectations. So yeah, every single time you press send, you'll get about 5 test fill. If you want to run a miner and you want a lot of test fill, you can always DM me on Slack and we'll get you a whole bunch. So you don't have to keep answering those questions to get your test fill. Cool, so that will get your wallet set up. So then after that, we can hit straight into the terminal to get it deployed. So you'll head over here. Very easily, you would just clone the whole repo. Yep, done pretty quickly. And then, as I mentioned, you would export your private key. Please do not use your real private key or deploy it if it's your real private key. Here, and then I have my private key copied out over here. But again, I mentioned this is not a real account, so nothing for you there if you want to hack it. Okay, so then now we have my private key in there. So let's test it out. Let's see if we'll get our address. So yarn get address. Cool. So we do have my address over here. And this would be the address that you saw from the MetaMask account. But then over here, you also see an F4 address. What that actually means is, so we are Ethereum compatible and we want you to see the OX address, but in the Filecoin network, we have an address manager that converts it to an F4 address. So if you see an F4 address and an OX address, they are the same thing. With a lot of our tooling, we've made sure that you can key in your OX address or your F4 address and you'll get the vice versa version of it. So it should be pretty easy to use. Don't get confused. Whichever one you prefer to work with, just use that. Cool. So now we make sure that the address is there. What we're going to do is we're going to deploy all the contracts in here. So as I mentioned earlier on, we have a few test contracts in there. So if you head over to the contracts folder, we have a few examples for you. We have basic solidity examples, which is just a simple coin, just making sure that you can do it ERC20. We have a quick start on our documentation page that will show you how to mint an ERC20 token on Remix. So super easy to use. You can just follow the steps over here. I'm not going to go through that. But yeah, you can then you can mint your token. So if you want to mint it as part of your project, you are able to do that as well. Where was I? Right. And then the other one, which is, I would say pretty interesting, is the deal here, Filecoin API examples. I have one example over here. So if you want to see how you can import the Filecoin Solidity library, you could just use this contract to just check if it works, but honestly, it doesn't really do much. We also have a deal rewarded contract, which is an off-chain version of the client contract, which is the main recommended flow of how you can store data. So this deal rewarded contract over here is actually an initial way that we thought we could store data. What we do is that we put a bounty into an escrow, and then we incentivize a bounty hunter to come and pick up your data and then do the usual more manual method of running a node and proposing it to a storage provider on the network, getting the deal ID for you and returning you the deal ID to then unlock the bounty within the smart contract. It's a bit of a roundabout way. That was the initial way, but we can see it working for certain use cases. So for example, if you have a designated storage provider that you want to work with, or you have a DAO and you want to designate one person to be in charge of making sure that these storage deals go through, you could use this method as well. Although Obviously not as streamlined, but it is an option for you. So that will be over there. And then what I'm going to demo is the deal client. So this is the deal client contract. This will allow you to basically be able to take any JPEG or any piece of data from wherever your dApp takes data in from, and then be able to deal with the whole deal proposal process for you and return you a deal ID. That should all be accomplished within anywhere 15 minutes to a half an hour, and you should get your deal ID back. Again, because this is decentralized, we are working off a network of storage providers that can choose when they want to accept. So it is dependent on them on how quickly they accept, but we have incentives for them to accept it much quicker on the mainnet. On the testnet, however, you'll get it really quickly in like 5 to 10 minutes because we have dummy miners over there that will accept your deal regardless. Yeah. If you want to run a local net, yeah, I have a few options for that. I can show you how to do it. If you run it locally, you will basically run your own miner and then your own node, and you would run it within your own environment. So yes, it will be much faster because you can just accept your own deal. What? Oh, for the hackathon, you could run it on your local net. Yeah, you could do that if you want to. Yeah. Yeah, we have a Docker image that we just created 2 days ago that lets you run a load. It's actually in the cheat sheet. You could spin up a Lotus image on the miner yourself. Yeah. So it should be pretty easy for you. So before I get into the deal client, I'm just going to explain really briefly on what happens. So we're going to prepare the data first. I have some dummy data that I prepared over here. Again, these resources are all in the cheat sheet, but we'll usually go to the data depot first. As I mentioned in my step-by-step, we are going to prepare the data. So while we prepare the data, I'm going to spend it takes about a minute, so I'm going to deploy all the contracts first. So I'm just going to go yarn hard hat deploy. It's going to deploy all the different contracts in there, so we'll let it run in the background. In the meantime, we're going to prepare this. So if let's say you want to upload a new file, it's actually really easy. You could just head over here, whatever files that I have. Cool, yeah, we'll just use the FVM logo. So if you put this in over here, I think because I uploaded it previously. Okay, I guess I'll upload a photo of myself. Right. And so yeah, it was actually uploaded. So now I have 3 files that I've uploaded. And for every single file that I have over here, there's actually a really easy interface for you to have, and these will be more useful. Like you will see why you need all these fields later on. These different fields are parameters that you have to include in your deal proposal to then emit your storage deal proposal to the network for your storage providers to accept. So we make it much easier for you. Usually we have a CLI. You can also use the CLI method if you prefer. I just find this a lot easier to read and explain. Yeah. So you have file ID, you have file name. You usually have a PC ID. I think that's still being computed. So I'm just going to use one that exists right now. Yeah, you have a PC ID, a payload CID. These are all fields that you need to key in. And we have a really easy way for you to see what you need to include. So we've written it over here. So if I copy this and I add it to a file, how do I make this larger? Oh my god. Hold on. Cool. So yeah, this is the template that we have for you. So all the fields that you saw earlier on, you can just input them based on what you have, like the contract address that you've deployed, which is deploying now in the background, and I will include that in a second. And then you have like the PCID, piece size, start epoch, end epoch. As I mentioned, epochs are like the blocks that run. Tip over here, I would recommend that you set an epoch that's about 5,000 epochs ahead of the current epoch, and you can check the current epoch based on our block explorer. So we have a really good block explorer over here called Filefox. We have about 7 block explorers in total that support FVM. Filefox is one of them and also one of the most used. So you can always go here and see for that. Make sure you're on the hyperspace network and not the main network, that you're actually looking at the right epoch. and then you can see what block height is at. I would suggest your start epoch and end epoch are about 5,000 a hit. So I would usually put like 258971, and then my end epoch would be another 5,000 on top of that, which would be, sorry, my math's not great, but 270, right? Around there. So you key in those epochs because if you put it too soon, you're going to miss the time when you're actually emitting your deal, and you're going to miss the epoch, and your deal proposal will not go through. If you put it too far ahead, you're just going to wait forever until the epoch is hit and your deal proposal goes through. So that is the most recommended. 30 seconds. Yeah. So yeah, let's check if our contracts have deployed. Okay, we're down to the last one, which is great. That will be the deal client. So once that is deployed, I will have the contract address, and then I can input it into that template I just showed you, and that will be the hard hat task that we want to run in the terminal. So once I have the contract address, I will input it in there. I will input all the other fields from the JPEG file that I uploaded, and then I can copy and paste that whole hard hat task and key it in here into my terminal and run it. And once I run it, I should have the deal proposal successfully emitted. And then we're not going to wait here because then that'll be the end of my talk, but it'll take about 15 minutes for your deal ID to come through it. And I'll show you how you can use the Block Explorer to then find your deal ID based on the proposal that you emitted. Okay, cool. It has now deployed. So as I mentioned, I'm going to take this. Okay, so I have one that I filled out earlier on. I'm just going to increase the font size. Cool. So I'm going to change out this contract address over here, and I have already filled in all the other fields, which is, it'll just take a while. So I prepared it in advance. So I have the whole hard task over here, and then I head back to my terminal, and I just need to drop this in over here. And it's making its deal proposal. The last time I did it, I think it took me like 30 seconds or so, 30 to 40. But while we're waiting for that to happen, I'm going to show you how you can check whether your contract has been deployed. So you can always take all the contract addresses that have been deployed over here. So I'm just going to copy the deal client, and I'm just going to search it on the Block Explorer. And yeah, it should show you pretty instantly that your deal is already submitted successfully to the network. And if you're actually doing this on mainnet, we definitely suggest that you verify any contract that you deploy. Really important to do verification over there. And I think Filefox and one other explorer, which is Barracks, has now implemented contract verifiers as part of their Block Explorer. So that should be pretty easy for you. Cool. So while we wait for this, I'm going to talk through briefly the next option. I know we're almost at time, but I just want to raise this other thing. So I'm going to bear in mind that if you use this method, you probably have to, what you will do is to import the entire deal client into part of your stack and run it as part of your dApp. If you prefer to not have to deal with the whole lot of that, and you just want to use a storage helper, which deals with a lot of the deal proposal, filling in all the blanks, preparing the data, etc., you can just use Lighthouse. Lighthouse is one of our partners, and they've built a storage helper on top of FVM. The cool thing about Lighthouse is that they also provide the additional option of access control. So they have a really easy to use SDK that also provides encryption for the data that you want to submit. So depending on the project that you're trying to build, if you need access control, you can also use Lighthouse Storage. This is also in the cheat sheet, so it would be easy for you to click on. Hooray! Okay, so event emitter proposal ID is out there right now, floating in hyperspace. How you would check whether your deal ID has come in or not is you would head to the Block Explorer again. You would head over to deal list. And this piece is not, I admit, it's not the most intuitive, but it's a stopgap solution for now, and it will work. You would just need to key in your address and then constantly check, because I actually submitted a deal earlier on, but then constantly check whether your deal ID has come in or not. So I usually refresh it after about 15 minutes just to see my deal ID has come in based on my address, and then I'd be able to refer to that deal ID as part of my dApp. Yeah, again, not the most intuitive. We are working right now on improving the workflow and being able to automatically notify the client once your deal ID has come in, but as of now, not available just yet. Okay, so that was mostly the demo. I have very little time left. I'm going to try to just cover how you can use FVM. If you're wondering, sounds cool, I'm in, what can I do with FVM and storage? We have a really long list of ideas at rfs.fvm.dev. You can look through those. Those are all storage-focused solutions with FVM that you can build. Also, once again, we have $10,000 for our prize. There are a few key categories over here. Programmable storage markets, so anything that will improve the data economy, in this case meaning Filecoin. So if you're thinking of perpetual storage, is really interesting to us. So how do you get storage deals to keep renewing? And if they have any issue with them, automatically repair them on the back end. Very interested in that. Data DAOs, very cool topic that is agnostic to Filecoin alone, but we think it can be used in a much larger way. You know what DAOs are, and now you think of data DAOs. So if you have a very important data set that you want to gather a DAO around, like for example for decentralized science, we see a lot of cool projects that are actually building already on FVM. So I'm just going to show you guys one because I thought this was really cool. But yeah, this team Puro, they actually built a decentralized science app on FVM. It's a data DAO basically, and then everyone just uploads their scientific papers, and then the DAO will help them. DAO members are incentivized to help to review these papers and then post their reviews in the DAO, and everything, the reviews and the papers themselves are stored onto Filecoin. So just seeding some ideas over here, and compute over data, also a really big piece. FVM can be used to orchestrate all these jobs for off-chain computation. We have a very efficient and good compute over data framework called Bacalhau. My teammate Irina, she's around at the booth. She's over there, can't miss her. But yeah, talk to her if you want to figure out how you can use FVM and compute over data. The cool thing is that, again, with decentralized science, you could then take the large data sets and do computation off-chain and then return the result to your dApp. So yeah, we kind of want to see more of that. And then lastly, infra and tooling. So if you want to build any cool tools that will help to, if you want to figure out how to automatically send a deal ID back to the client and fix my demo, I would mostly welcome that. I will award you a prize if you can do it. But yeah, some tooling ideas as well. And then we have a wildcard category. So anything cool that you can come up with, please surprise us. Yeah, and then lastly, I do want to touch on that if you're building beyond the hackathon and you want to keep building, we actually have a lot. We have all these integrations that are already launched in the past month with FVM that are compatible with FVM. So we have containers for setup, we have cross-chain messaging and cross-chain token bridging, we have oracles with Telor, access control I just mentioned with Lighthouse and Medusa as well. We have some DeFi solutions on liquid staking, and SushiSwap is coming in really, really soon as a DEX. We also have network analytics APIs if you want to use it as part of your project. Decentralized compute, and these are all resources that you can find in the hackathon cheat sheet. They are not only on mainnet, they are also on Hyperspace, and I have the contract addresses on there in the cheat sheet, so if you want to use them, just hit in there and use it as well. But yeah, I just want to let you guys know that there are many other integrations that you can build your project out with. Yeah, and as a judge and with my other judges, these are the things that we're looking for. We're looking for storing files with the FVM client contract that we just showed, storing files with a storage helper like Lighthouse. It could be either or. And then making sure that your project is deployed to Hyperspace testnet. We do want to make sure that you're using storage well, or at least as part of your dApp, and not just deploying your contract with no storage components or nothing to do with FVM or Filecoin onto the Hyperspace testnet. Just want to put it out there so that you don't waste your time deploying to Hyperspace, but that's what we're looking out for. And any innovative and creative users of storage. So yeah. Link QR code, this is at the booth as well. The hackathon cheat sheet is in there, as well as our docs, the RFS fvm.dev, and upcoming hackathons and grants that you can access. So yeah, that was a lot. I am around for questions, but I don't want to take up the next talk. So thank you, everyone.
Thank you.
Are we good to go? Awesome. Hey everyone, thank you so much for coming to this session. I'm going to really quickly show you how to bootstrap and deploy your dApp on Polygon ZK EVM. But first of all, GMGM, or as we've switched to ZMZM since we're kind of like in this ZK universe, I'm Steph. I'm a developer relations engineer at Polygon Labs. I'm also Oceans404 on Twitter. And a fun fact about me is I got started in Web3 because of hackathons just like this. So I'm super passionate about building things and helping you all build things. And one of the things I struggled with when I was doing hackathons is like building really quickly. So the goal of this session is to show you how to use Polygon ZK EVM really fast. So how to bootstrap something quickly so that you can focus more on your business logic and the hacks and the real world problems you're trying to solve, and less on like, oh, how do I connect my wallet, or what is specific about ZK EVM. But that said, I will go over a few ZK EVM things, but first I just want to highlight our 4 different prize categories for builders. So we have 4 categories. The first one is the best cross-chain or X-chain hack with Polygon ZK EVM. So we want to see you connect to either Ethereum or Polygon POS or some of the other L2s and use that data in an interesting way, whether you're connecting it for governance or like having mints based on owning tokens on another chain, something like that. Next is 5,000 for Polygon ID verified credentials. So implement identity in an interesting way. Next, we've got the best public good with account abstraction. And I don't know if you noticed, but account abstraction has kind of been a theme at ETHGlobal Tokyo this year. And we're really excited to see all of the different account abstraction hacks. So if you did that on Polygon, you'd be eligible for 3 different bounties. So you could triple up if you did a really great hack. Highly recommend that. And then the last one is our Polygon Build in Public pool prize. So if you deploy on any of our chains, you're eligible to split this prize with however many people also deploy. So really encourage you to deploy any type of dApp because we want to see what you're building. But we had a really exciting announcement on the 27th of March, and that is that we launched Polygon ZK EVM mainnet beta. So it's on the mainnet. You can deploy dApps to it. You can test it out. We've had our testnet for about 6 months, and over 70,000 developers have developed smart contracts, and it's started to be battle tested. So excited to see you develop on Polygon ZK EVM this hackathon. Why Polygon ZK EVM? We think it's the next chapter of Ethereum scaling. It's exciting for developers because you can use all the same tools and technologies you're already used to, whether that's building with Hardhat or Remix or Foundry. They all work out of the box. You can use Solidity the same way you would for Polygon POS or Ethereum. And it just works pretty seamlessly. The only thing that I have to call out is that we don't support 4 precompile opcodes. So if you're building something with those aren't supported, but for the most part, everything should work seamlessly, which is great for developers. So the first half of ZK EVM is ZK, zero knowledge, and I like to explain this with an example. Did anyone play Where's Waldo as a kid? Those books where you look for Waldo? I know I did. So Waldo is somewhere in this picture, and I could prove to you that I knew where he was without telling you exactly where he was. And I could do that by highlighting where he is in the picture and covering it with a big piece of paper. So on this picture on the left, there's a big purple piece of paper in front of the actual Waldo puzzle. And so you can see that I know where he is, but you don't know exactly where I've positioned this piece of paper. So that's kind of like a ZK proof where I'm proving to you I know where Waldo is without giving you the information to show you where he is. So you don't know exactly where he is, but you know that I know. And I kind of like took this example from a cool Wired video where a computer scientist explains ZK with 5 levels of difficulty for a little girl. He has like a penguins and puffins example. But when this is kind of done in the real world, it's done with cryptography, which is complex math, to prove a statement or like a batch of transactions in this case is valid without actually needing to have all of the data there. So this is really great because it can be secure and private, but that's not actually the focus of ZK EVM. It's more for increasing the throughput of Ethereum and adding kind of like to the efficiency. So ZK proofs help you prove that you know something without revealing any additional data about what that thing is. So that's the first half of ZK Rollup or ZK EVM. So we know what ZK is now. The other half is what is a rollup. So a rollup is a layer 2 scaling solution. It's where you take a big batch of transactions and you do something interesting with them and you just post a small amount of data on the L1, which is Ethereum. In the case of a ZK rollup, you're taking a big batch of transactions from Polygon ZK EVM, and instead of having all that data on Ethereum, you just have one single ZK validity proof that says, okay, all of the state changes that changed on ZK EVM are valid, and we can just have that posted on Ethereum, which drastically decreases the amount of data there and increases the throughput and adds to lower cost transactions for each of those batch transactions because there's only one thing that's finally posted on Ethereum, and that's that proof. So why Polygon ZK EVM? First of all, it's great to inherit Ethereum's battle-tested security. That proof is being posted on Ethereum, and Ethereum has been running successfully for years and years. We trust it. We love it for DeFi. That's awesome. Second reason is achieving true EVM equivalence. And when we have that, the things that function on Ethereum also function on ZK EVM. So you don't have to change functions or anything. The code works the same way. Third reason is it's fast and performant. And then the fourth reason is lower cost transactions than if you were operating just on Ethereum. Some of the industry use cases and things that we're really excited to see you all build are things in the DeFi and traditional finance space. When you're transferring value, you want high levels of security, right? Because you don't want somebody to be able to change that transaction. So for finance, we highly suggest ZK EVM. Also for supply chain, infrastructure projects, healthcare, all of that, you need high levels of trust. So Polygon ZK EVM is the right choice when you're figuring out what chain to use there. So to get started building, the first thing you need to do is bridge over some ETH. So on the testnet, that'll be Goerli ETH. And then on the mainnet, it'll be just like real ETH that you would use on Ethereum. So you'll use wallet.polygon.technology and you'll bridge over those tokens so that you can use them on ZK EVM. And then once you do that, you can operate on this chain pretty much the same way you would with Ethereum. And I'm going to show you how to pretty quickly build a dApp. I worked on create Web3 dApp and added a Polygon ZK EVM network the other day with my friend Vito and the Alchemy team. So I'm just going to show you how to use this tool to pretty quickly create your own dApp and deploy to Polygon ZK EVM. So like I said, this is a tool that was created by the Alchemy team. All I did yesterday was add support for Polygon ZK EVM. Here are some of the other chains that are already supported. So Ethereum and Polygon were already supported, Arbitrum and Optimism. And the cool thing about this is you can get started pretty much as easily as you can with Create React App, if anybody's ever used that. So I love this tool because it bootstraps a front end and helps you create like the smart contracts that you would need for anything you're doing. So I'm just going to open a command line tab. So all you have to do is run npx and then create web3 dApp at latest. And this will just start that package creating a web3 dApp. So it's beginning to bootstrap, and it's just asking me for some details about my project. So I'm just going to create a simple NFT project because I think we're all familiar with NFTs, just so that you can understand how this tool works. So I'm going to call it Tokyo NFT. So then you can either choose to create a full stack dApp or use a template. I'm going to just choose the full stack dApp so you can see the full workflow. You choose your chain. So I'll choose Polygon ZK EVM. And you can choose your development environment. I'm going to use Hardhat. And the beautiful thing about ZK EVM is that it works with Hardhat, Foundry, Remix, all the things that you're already used to building with. Do I want to create a smart contract? Yes. And then since we're just going to do some NFTs today, I'll choose ERC 721. But as you can see, you could use this if you were doing something interesting with tokenomics. You could do like an ERC 20. You can also do, I believe, a governance contract if you were doing something with DAOs. And then name for your contract, let's just call it Cherry Blossoms. And symbol CBS, I guess, or just CB. That works. Okay, so now it's asking me to toggle some features. If you've ever used OpenZeppelin's wizard, I think I spelled that completely wrong. If you've ever used the contracts wizard from OpenZeppelin, it's using this same API where you can pick whatever token you want and add features. So we're just doing this from the command line. So I would like my NFTs just to auto increment and also have URI storage. So auto increment just, oh wait, I'm not done selecting. So auto increment just bumps up the ID every time we mint an NFT, and then URI storage means that we can create our own like metadata for the NFT, whether that's image, title, whatever we want there. So you could also add any of these other features if you wanted to, but since this is going to be a pretty simple demo, I'm not going to do that. I'm done selecting features. Next, it's just asking me if I already have an Alchemy account, which I do. Alchemy allows you to have RPC URLs. So I have a bunch here. I created this key a day ago, so I'm just going to reuse it. And I'll delete it after this demo, so no one will be able to grab my key and know it. But I'm just going to paste it back into the command line. And now it's creating this full dApp boilerplate for me. So it's going to give me all of the dependencies that I need for this, and it'll have a front end and a back end. So it'll create this hard hat repo for me, and I'll basically have the shell of everything I need to do. So all I have to do next is like my business logic and a tiny bit of front end, which in a hackathon setting is great, right? Because you don't have to figure out, oh, shoot, how do I add Wallet Connect or Rainbow Wallet or anything like that. It just is already there. So all you do is focus on whatever you're actually hacking on, which I love. The other really cool thing that Alchemy has is some component libraries. So let's just check those docs really quick so you can see what's available. If I was hacking this weekend, I'd probably use a combination of the component libraries and then something like Material UI or Chakra to have a bunch of components so that you don't worry about all of the styling. But the components that are available out of the box for Alchemy are some things that include like an NFT minter, and I believe also a ERC20 claim. So those are both great for really quick bootstrapping. Okay, we're almost there with the bootstrapping. And this is installing all dependencies. So once it's done, really all I'll have to do is run like npx hardhat compile, and I'll have everything I need to deploy my smart contract. Come on, Wi-Fi. This is what I get for doing a live demo. Okay, awesome. So as you can see, there's two more things to do. Add your private key in the .env file, and then run the application. So I'm just going to copy over an env file that I have already, and I'll just add it to... So this is just copying it into my backend folder because I don't want to show you all my env file. But now I've got that, and I can just run the front end command to bootstrap our front end. So I'll copy this in. It is running on localhost. Let me just open this up in Chrome. And this is what we have out of the box from Alchemy. Like I said, this is the bootstrapped site, and we have a connect wallet button. I'm just going to use MetaMask. You can see I'm already connected to the ZK EVM testnet, and that was all done for me. Didn't have to do a thing, which is pretty awesome. I don't know if you've had to do this from scratch ever, but it can be painful. So this is great. And then the last thing I'm going to do is just deploy my smart contract. So this was the front-end repo that was generated. I'll just show you the folder structure here. So we've got a backend folder and also a front-end folder. The front-end folder is just a Next app that looks like this. The backend folder is really similar to a Hardhat repo if you've used Hardhat before. And all of the commands are the same as well. So let's just cd into backend. And then the Hardhat command is npx hardhat compile. And what this is doing is it's taking the contract that we bootstrapped from the command line. If you remember, I called it Cherry Blossoms. I had this as the short name for it. And you can see that we've bootstrapped this with the URI storage, access control, the counters, everything that we asked for in the command line. So it was pretty simple there. I ran Hardhat compile, and I've got all of those Solidity files successfully compiled. And let me just double check the command for actually deploying. In my package JSON, it looks like it is npm run deploy testnet. So that's just going to run the deploy script that was also created when this was bootstrapped. And just to show you, this is our Hardhat config that was also created for us. In the networks object, you can see we've got Polygon ZK EVM mainnet and also the testnet, and those both have our Alchemy keys that we added. So I'm just going to run that. npm. And this will just start to deploy to Polygon ZK EVM testnet. And we should be able to see the result of this in the testnet explorer. So we've got a testnet and mainnet explorer. They look very similar to Etherscan if you've used those before. They're just at zkevm.polyscan.com. And you can switch between mainnet and testnet in the explorer. Let's see what the contract address was. So Cherry Blossoms, our NFT project, was deployed here to this address. And yep, it was deployed about 31 seconds ago. So the only other thing we have to do now is hook up the front end. You can do that using those really nice components that Alchemy provides. So I'm just going to pull up the components really quick so I can reference those as we add them to the front end. OK. So back in CW3D, which is just create Web3 dApp, checking out the components. So you can either use collection display, creator, minter, or gallery. I'm just going to look at minter so we can mint the NFTs from the front end really quickly. It's asking me to create two files. One of them is an NFT minter, and the other one is just some styling. I'll show you what that code looks like. They've got really nice copy-paste abilities here. I don't trust my copy-paste, so I'm just going to grab them from my Finder where I pasted them earlier today. So I'm just going to put NFT minter inside of front-end components. And then the styling can just go in the styles folder here. And then the only other thing we have to do is actually import these. So we'll just add these to the page. Components, pages, index. OK. I'm just importing those two components to the front end. And then it looks like this takes a few props. So it's asking for the contract address and then also the, let's see, if I save this, that'll format it a little easier for us to look at. OK, so first thing we need is the contract address. We know that from our command line. This was where we deployed about a minute ago. So just adding that here. And then for the token URI, I'm just going to upload it really quickly to NFT storage. I created one of these a little bit earlier as well. It's just going to look like this. typically a token has a title and then a description and an image. Since this is cherry blossoms, I'm just going to use an image I took 2 days ago at one of the gardens here, just some beautiful cherry blossoms. I thought I missed the season, but luckily got one more tree in, so this one was waiting for me. But let me just go to NFT storage. This is a place where you can upload to IPFS really quickly. There's also like an API, so you can do it programmatically. But today I'm just going to upload. Where is it? Let's see. Desktop, Tokyo Hackathon. So just uploading the token URI here. It'll spit out an IPFS link, and I'll just add that to the front end. So let's see, is it this one? Nope. Okay, we'll just use that one for now. Back in the index, I'm going to change the token URI. And then the very last thing is the contract ABI. This is what gives our front end all of the knowledge about like what the contract actually looks like. So I'll just grab this from the back end in, where was it? Artifacts, build info, and then, no, artifacts, build info, and contracts. So I'll just copy this contract into the front end. And inside of NFT Minter, where am I putting this? Sorry. I'm just moving this file out, and we'll just reference ABI from this file inside of index. So import contract from. All right. If all went well in this live demo, we'll see a updated, let's see, where did it go? I'm hoping to see a minting site. Looks like it's loaded. Oh, here it is. Okay. So I'm going to mint now. We could improve the CSS, obviously, but this is the general minter. Gas seems to be weirdly very high, but we won't worry about that quite yet. And I'll go back to the contract, and let's see if we got that minted successfully. So we should see one new transaction that is a mint. Whew. Here it is. Let's check it out. Nothing ever works for me the first time, so I'm kind of impressed by this. So hopefully we'll see the NFT minted to this address, and that will be our create Web3 dApp demo on Polygon ZK EVM. So if I can do this in 30 minutes, you all can definitely do this within the 2-day hackathon. But come on, Wi-Fi, let's go. We'll see. Okay. I'm going to go back to the presentation. There's just one more slide, and it is a QR code to the docs. And then if you need any docs this weekend, this is where all of them are for Polygon ID, ZK EVM, POS, our prizes, everything. But I'm Steph, and I'll be at the Polygon booth all weekend. So if you need encouragement, if you need help, come say hi. And I'm happy to help with anything you need as you're hacking, whether it's Polygon or anything else. Love to talk about Web3. But let's go back and see if this actually loaded and worked. Please, please. We might just have to assume it did because I don't know if the Wi-Fi is loving me right now. But hopefully we've got an NFT of a cherry blossom. Thank you so much. I'll just let it load until our next presenter comes. Oh, yay, we've got it. Yay.